a bit of maybe a few minutes and then we'll kickstart. Okay, great. All right. So the last time when we met, we started with data collection. We did more or less overview of data collection, and then we look at some of the approaches, okay, that we use for data collection, the primary and secondary. And then we also talked about various types of data, that is qualitative and quantitative. We look at their various classification, that's the, we did the categorical data, and then from categorical data, we split it into nominal and ordinal. And then we also move on to the quantitative, and the quantitative one, we talked about how the numerical aspect of it, we can get the that's discrete. Okay, we can get the discrete and then the numerical, and then yeah, and then from the numerical we talked about that's the, so the discrete we said is involve counting, and then the numerical are more or less continued. That's the interval ratio detail. Okay, they can assume decimals. Okay, I think so. Basically, that is where and then we did some trial questions, of which my women, my ladies, my wonderful lady didn't disappoint me. They did so well, very impressive as you are. And yeah, so today we're actually going to talk about sampling, which is not that difficult. It's very, very simple, but there's some small aspect of calculation in it, some parts. Okay, even though I'll try very hard to avoid calculations, okay, for now, but the calculations are definitely will be doing some calculations. Maybe not today, maybe in our next meeting. So we should try, and then those who don't like mathematics, please prompt me in case the thing is becoming too mathematical and your head is spinning. Just give me a shout out, and then I'll be able to go down a little bit, okay? But something is not difficult at all, okay? At all. It's very, very, very simple. Okay, great. So,
today you won't get your ladies.
Yes, in fact, my ladies are, yeah, I greeted them in the initial part. I told that they are welcome, especially my ladies. Okay, so let me give a shout out because the men have reminded me. Let me only give a shout out to all my ladies in the class. So Charity, I see you. If I see you, if Emilia, welcome to class. Lizzie,
Thank you.
Emil, that's Emil. I also see you as well. Mary, oh Mary, my mom. That's good to see you in class. Jocelyn, I see you as well. Okay, Sammy, are you? Sammy, are you a lady? Please, I don't want to see your hand up. Okay, Sammy. And then Nash, I think Nash is a lady because the voice I normally hear from that side is a lady voice. Patricia, good to see you in class. Rita, good to see you. And then Nimatu, good to see you, Nimatu, good to see you. Still, there are a lot of my ladies who are not in class today. I don't know what is happening. Okay, no. Are they still in the spirit of church?
They are dancing it out in the churches.
Oh my God. Okay, that's true. That is true. That is very, very true. My ladies are very spiritual. Oh my God. How can I teach when my ladies are not in class? Oh, that'll be quite painful because
So you're also spiritual too.
yeah, I know. The men they hardly, but my ladies they are. Okay. All right. So I think we need to start now. Okay. We need to start now. I think they can join us later. All right. Now, so let's start with something. When we talk of sampling, okay. You see, looking at the notes that I gave you, I don't know, I gave you the PDF notes that I gave you. If you look at the PDF notes, I don't know whether you've gone through it. The PDF notes that I gave you, I don't know. Please, have you gone through the PDF note that I gave you? I don't know. Have you gone through them? Yes, please. Have you?
Also,
Oh, please. The PDF. The PDF is more or less the guide for the class. Okay, so please try as much as possible to go through them for me. Please, please. Okay, I know that I'm not following it strictly, but there are some things in there that I want you to get them. So use the PowerPoint that I'll be sending you. That please make sure you go through that one as well. Okay, please, please, please. This one there. That's my humble plea. Okay, okay. So the PDF that I gave you. Okay, good. So you see, when it comes to data collection, you know, sampling. Okay, when you are going to sample data, there are two main things that we do. Okay, so for instance, let's take it this way that I have population. So let me enter. Okay, so let's say if I have population, it's ideally, okay, population. Okay, so when you are dealing with population, let's say the population means that, okay, it deals with the entirety. Okay, every individual is accounted. It's accounted for. Okay, accounted for. All right. So anytime you are dealing with population, the entire population, you make sure that you count everyone. Okay. If I'm going to work on data on what? On population. Okay. Data on population. You make sure that every individual is what? Is actually accounted for. That's particularly important. Okay. And ideally, we expect that anytime you're working on data, we should get the population. And so, like for instance, in a school, people are going to write exam. You see, it's the entire student who are going to write exam. So the number of people who wrote the exam, that's population, because every individual is accounted for. Okay, so that is not sample. Okay, so let's take it this way, that how many people are in the class? That is population. We are dealing with everybody. Okay, so let's say all the kids in class 2, that we are talking about what? Population. Okay, we are talking about population. Okay, population. Okay, so because everybody in the class is accounted for. Okay, great. And so ideally, that is what we want. We want that the things that we do, we should have the entire population in mind. So all the kids in the class, that is population. Okay, great. And so any sort of measurement, any data that any measurement that we do on the population, okay, like any sort of measurement, okay, that all those measurable attributes, okay, of the population, we refer to it as what? As parameter. So those are parameter. Okay, so parameter deals with what? Those measurable what? Attributes, attributes of the population. Okay, so measurable attributes of the population. Okay, that's what we call parameter. So I can talk of the average, the average age of the class. Okay, the average age of the mean age. Okay, the modal age, and then the what? The mean, what's the third one? The mean, the mode, and then the what? What's the third one?
The median.
The median. Yes. So those things, if I'm doing it for so for instance, if I'm doing that for mean, mode, and what? Median, like that. Okay, for the population, if I'm doing it for population, those things are called parameters. Okay, all right, great. So that is parameters. But sometimes, so ideally, okay, we expect that when we are working, we should work with population, because population, everybody is accounted for. There's nothing like bias, nothing. Like everybody in the class was accounted for. Okay, so that is parameter. So those measurable attributes of population, we are referring to it as what? As parameter. Now, here we are. So for instance, let's take it this way, that in Ghana, if I want to do something to know almost everyone in the population, how will I collect my data? approach that I will use to collect my data? Can you tell me? What will I do? If I want to collect I want to know everybody in the population, everybody. What will I do? I just want to know, what will I do? Mm-hmm.
You use
Yeah,
census.
I will do census. That's beautiful. Well done. Oh, my ladies are back on fire. Thank you, thank you, thank you. I'm so happy to see you here. All right, great. So we'll do census. So you see that the census will more or less take everybody, okay? All right, great. So anytime you are talking about what? If I want to account for every individual in the population, I'm going to do what? If I want to account for every individual, I will do census. Okay, so census will make sure that almost every individual in the population is counted. Okay, so that is census. So if I'm working on what, how will I get and so here in this case, for me to get the word, the members. So to get the members, so to get the word, so let me go down here. To get the members, all the members. Okay, so all the members of the word, members of the population. I need to what? I will carry out, I will perform what? Census. Okay, so in census, every individual is accounted for. Okay, so that is how I'm going to get the units of the population. Okay, you count virtually everybody. So in the school, even if they are in the school like that, even if there are 1,000 people, we know everybody there, literally, because in the school, we always want to account for everybody in the school, whether they in JSS or basic school, or even people are writing exam, we can actually give an exact figure because basically everybody is accounted for. So that is population. All right, good. And population is good because in this case, everybody is accounted for. There's nothing like bias or there's nothing like anything that we say, no, nothing. We can't say anything against it, because that's the ideal thing. And we get the individuals of the population by performing what? By performing census. Beautiful. So anytime once you get everybody accounted for, we're going to do census. Okay, good. Now, but there are some instances whereby getting the population is impossible. It doesn't matter what you do. It doesn't matter. So there are situations, so okay, so there are instances where getting the word, getting the population is virtually impossible. Okay, impossible. All right, it's virtually impossible, right? So if it is impossible to do that, what can we do? Okay, what can we do about that? In this case, then which means that we need to rely on something we call sample. Okay, are you with me? We need to rely on sample. So what is sample then? Yes, what is sample? Yes, somebody should help me. What is sample?
Hello, sir.
Yes, please. Mhm.
Okay. Sample means taking a portion out of the bigger population.
Okay, all right, great. Taking a portion out of what? A bigger population. Okay, good.
Hello, sir.
Yes, please. Mhm.
You can also say that sample is a subset of population.
It's a subset. So okay, good. So okay, so let me highlight this one and take the point you are saying. So we are talking about sample here. Maybe let me make it a sample. So sample, our brother said what? Taking some parts of the population. Okay, and then another person has become very mathematic. Okay, he's so mathematic by using the word subset. Taking the subset. So some parts. So I will, so some parts here will be, let me put it here, will still be a synonym. Okay, a synonym of some parts. Right, good. Okay, great. So something like this. Okay, so we taking some parts of the population or the subset of the population is what we are referring to as sample. Okay, great. Now, so my question is, at what instance that sample becomes the option? Okay, so sample, at what instance that sample becomes the option? All right, at what instance that sample, hey, me
Okay, sir.
those of you at church, please mute your mic. Okay, so that, all right. So at what instance that sample becomes option instead of population? Yes.
Okay, sir.
Yes, please.
Okay, sample becomes the option normally when census is impossible.
Okay, census is impossible. In what instance
Yes.
do you think census is impossible? Can
When
you
the
give?
population is too much to work with.
Okay, that's nice. Okay, so when the population is so large that we can't actually get every individual, so in that case, we don't have any choice than to use what? Than to use sample. Okay, good. What else again? So so here, what we are saying here is that our brother is saying here is that so sometimes sample, sometimes sample becomes becomes our word, our best choice because the population becomes what? Maybe obtaining the whole population becomes difficult. Okay, maybe getting, okay, so let's say one, when getting the word, getting or obtaining the entire population is difficult. Okay, difficult. Okay, difficult or cumbersome. Okay, so that is one reason when obtaining the entire population is difficult or is cumbersome. Okay, what else again?
Hello there.
Okay. Yes, please.
Can we also say that when the population is too large?
Yes, I think it will still be part of it. Okay, the too large means that it's difficult to get everybody. Okay, okay, all right, great. So maybe I'll still add it. Okay, maybe I'll still add it to here. Maybe too large to work for it. Work for it. Okay, still on the same point. Okay. All right, great. What else again? What else again?
So when the population are geographically dispersed.
When population are geographically dispersed, I think it will still be under this one. I think it will still be under this one.
Okay, then when the population are constantly changing.
The population is constantly changing. When the population is constantly changing, won't it still become part of being difficult and cumbersome? Because if it's still constant, okay, well, I think maybe I think I can still that. Okay, when the pop is constantly changing, it's constantly, I think that's also a nice point. It's constantly changing. Okay. All right. What else again? Okay. What else again? Sometimes it is impossible. Let me give you a scenario. Let's say if I want to count your red blood cells, how will I do it? Will I drain all your blood and count all your cells? Hello?
No.
Yeah.
No, sir.
So in this case, here, well, it is impossible. Trust me, we can't work on that. Okay, it is when it is impossible, okay, when it is impossible, okay, to work with what? To work with a what? To work with the pop. Like where? Like taking red blood cells count. If I want to count all the red blood cells, all the red blood cells, all the red blood cells, how possible? How can I do it? It is impossible. I can't. Okay, because I can't drain all your blood and count every cell in it. Okay, good. And then sometimes, so isn't it cost? Sometimes it is too expensive. Maybe it is costly. Okay, sometimes it is too expensive to do it. It's costly. Honestly, you see, that's why we don't conduct census every year. But it is too expensive to do it. Okay, to conduct census year after year is very expensive. So I think we do it after every 10 years or every 8 years or something like that. Okay, so it is costly to carry out what? To carry out census. Okay, so it is costly, and then apart from the costs can be labor and time
Conscious.
demanding. Okay, can be labor and time demanding as well. Okay, good. So it can be labor and time demanding. Sometimes you want the data quickly, and it's virtually impossible. You can't because of the way.
Okay, so what
Labor.
if the research involves destroying the population or
Okay.
destroying the things at hand?
Okay. Can you give me an example?
Example, if you want to maybe test the quality of a glass, you can't go and choose all the glass.
Exactly. Good. Exactly. You can't.
Something.
Exactly. So you have to take the subset. That's good. Even if our own drug, the drug that you can't say that you give all the drugs to the entire population to see its quality. Okay, to determine efficacy of the drug. You can't. That you give the drug that you have manufactured, you want to give it to everybody to see whether the drug is effective. I mean, you can't. Okay, it's virtually impossible for you to do that. Okay, so yeah, so sometimes the population may be too cumbersome or too large to work with. Sometimes it's virtually impossible. You just can't. Like the blood count. If I want to measure your red blood cell count in your body, there's no ways I'm going to drain all the blood in you, and then what? And then count it. No, it is impossible. I can't do that. Okay. And sometimes the population is constantly changing. So at any time you see that you measure, the next moment is changing. So in this case, you need to work on samples. And sometimes the cost, even if it is possible for you to do it, the cost, the labor, and then the time will be so much that it will actually put you off. Okay. So in situations, yes, please.
Please, can you also say that when you have a limited time to produce your findings?
Yeah, that's why time is here. That's why time is here. So sometimes when the time involved, you don't have the luxury of time for you to do the work. I mean, obviously time is limited. So in this case, if it is time demanding to work with the population, time demanding or labor demanding to work, okay, to work with the work, to work with the population, with the pop, okay, all right, so which means that we need to fall upon what sample. So when it is,
Hello, sir.
Yes, please.
I also say that materials and equipment unavailability to work.
Won't it be part of cost and labor? It will still be part of cost. If you have money to buy for everybody, you will. But if you don't have the money, let's take it this way, that your classroom, the class of maybe 50 students in the class, ideally you expect that maybe we should buy a state-of-the-art computer for everybody. But because there is no money for everybody to get one, you ask maybe 2 or 3 people to share, okay, or something like that. So ideally, if we want everybody, but if there's no money for everyone, definitely you have to sample, okay, and stuff like that. So yeah, so the equipment and stuff like that will be part of the cost and labor. So if it is working with the entire population, is cost, labor, and then time demanding, then it means that you have to fall upon the sample, okay, where it is impossible, like blood, okay, to get to the entire population, like taking blood count, red blood count of your blood, okay, or when the entire population is too large, too cumbersome to work with, then you have to rely on sample. Okay, good. So if I'm going to rely on sample, okay, now that we know that we're going to rely on sample, okay, now let me put my sample on top here. Okay, now those measurements of sample, those, you see, I say that those measurable attributes of what of a population is what we call it, what we call a parameter. So the measurable attribute of a sample is called what? It's called statistics. So this is where statistics, okay, comes into the picture. So those statistics deals with the word measurable attributes, okay, measurable attributes, okay, attributes of a word of a sample. Then that is, we are dealing with what? We are dealing with statistics. Okay, great. Now, so so now what you are going to see is that we are going to find out, right now we know why we take away, we take samples, okay? So we want to see what are the various sampling types are available, okay? Various sampling types available, and when do we use them? Okay, when do we use them? Okay, great. So honestly, we can actually, when it comes to sample the various, so which means that we have the I have samples there, and then so because I can't get the entire population, I need to get sample. So the method that I'm going to use to get a sample is called sampling. Okay, are you with me? So the sampling is actually the method that I will use. Okay, so method that the procedure that I will use to obtain to obtain the way, to obtain the members okay of the sample. All right, okay, great. Now with this method we can actually group them into two. What are they? We can talk of what? We can talk of probability.
Hello, sir.
Hello.
Please, is there any difference between statistics and statistic?
Statistics
And statistic.
One is a noun, one is an adjective.
Okay, is that all?
That's all.
Please. Okay.
Okay. So
Hello?
hello, yes, please.
Yeah, but I also think that one is maybe plural and then one is singular.
No, we don't. When you say I use let's say statistical approach in doing it. So statistics as a subject doesn't always go with the S. Okay, statistic as a subject, unless you are using the statistics to qualify something.
Okay, so
But statistic as a discipline always goes with S. Okay. All right. Thank you. So we have the sampling. So obtain them. So the approach that I will use to obtain the members is a sampling. But this sampling, I can have it in two main ways. I can do something we call probability sampling. Okay, probability sampling and non-probability sampling. Okay, non-probability sampling. Okay, so all right. So probability sampling, non-probability. So which means that when I use probability sampling, I will get probability sample. If I use a non one, I'll get a non-probability sample. Basically, that's about. Okay, now let's see something. Now, when you see that, when I'm dealing with probability, what does it mean? You know, when you talk of probability, when you say if somebody is talking, the person is probably. What's the meaning of the word probably? What does it mean? Yes.
So it means there is a high chance of getting something.
Okay, chance. Okay, good. So now the key word here is chance, right? Okay, chance. Now, anytime you are doing probability sampling, what it means is that individuals in the population from which you are going to do it. So anytime I'm doing probability sampling, it means that individuals in the population, in the pop, okay, from which the samples are going to be selected. Okay, the samples are going to be selected. All right. Okay, the samples are going to be, so the individuals in the population, okay, from where the samples are, those individuals, they have equal what? They are selected, have equal what? Equal chance of being picked. All right, being picked or being selected. All right, so that is probability sampling. Okay, so which means that before you start the sampling, individuals have equal chance of being picked. All right, of which probability sampling is more of not everyone in the population has equal chance of being picked. So for probability sampling, not everyone. Okay, I can say that let's take it this way that I do this, that people at a particular height. So obviously this is not everybody in the population. I do quota system, whereby I'm giving quota. So if I'm basing it on quota system, not everybody will have equal chance of being picked. Okay, so these ones they are not this type of probability is not every member of the population has equal chance of being picked. It's not based on probability, it's not strictly based on chance. Okay, all right, so it's based on quota system. Let's take it this way that let's say university admission is based on, it's not actually based on some, but sometimes they can do this, they can decide that, this year we want to increase the number of female intake. Okay, sometimes they could do that. Okay, maybe certain courses, like let's take it this way, that the engineering courses like that, usually my ladies, most of them don't really like engineering courses. So if few people express interest, okay, usually they will pick all of them. Okay, once they even if it is making the cutoff points, maybe +1, +2 for them, just to encourage the women to pick up engineering courses. Okay, great. So we have situations like that. So in this particular case, it's not everybody there that will have equal probability of being picked. Okay, all right.
Hello,
because yes, please.
Please, I want to know the difference between non-probability sampling and random sampling. Are they the same or they have similarity?
So we have random. So the probability sampling deals with random. There's randomness. Everybody has equal chance of being picked. Okay, we'll come to all of them. Okay, very good. We have different types of the random. Okay, so but we'll come to all of them one by one. Okay, I want to give the general before we go to okay, good. So probability sampling is based on random. So which means that individuals are selected randomly. That's basically so. Okay, so individuals. So here, individuals are selected randomly. Okay, all right, great. So here, everybody has equal chance of being picked because we are selecting them randomly. So from the start of the sampling, there is there's randomness in it. So before the start of the experiment, every individual there has equal probability of being picked. Okay, chance of being picked because you are picking them randomly. Okay, so from the beginning, see, I'm hammering from the beginning, right from the start. Okay, when I've also from the word, that's from the start. Okay, of the experiment or the study. Okay, all right, great. So that's it. Now, non-probability sampling is not what? It's not It's not strictly random. Some parts could be random though, but it's not strictly random. We can do something we call like a convenience sampling. You sample the people because they were close to you, because you were able to assess them. You understand that? You didn't sample them because you predefine your objective in the beginning that you are going to. No. You just sample them as at when they were available. That's more or less convenience sampling. Okay, and you can even do something like purposeful sample.
Yeah, okay.
Hello.
Oh.
Is there any question for me?
So please, sir.
Yes.
So maybe you are a teacher and you are in a class, and you want to perform an activities with the learners. And if you choose those students sitting on the front seats for the learning activity, is it a convenient sampling?
Yeah, it depends on if you did it randomly and you chose those people in front, that is still random. That's still probability sampling. But if you deliberately chose
I
those,
deliberately do that.
So that's purposeful sampling.
Okay,
or you just deliberately let's take it this way, that they are coming to do some studies in the school. They want to the education people want to assess, evaluate the average intelligence in your school, and you, instead of you allowing the education people to choose the student randomly, you just decided to pick 4 best students in the class for them to go and sit for the exam. Okay, so in that case, this is purposeful sample, because it's not, okay, it doesn't reflect the population. Okay, you chose people purposefully to go and sit. So that's non-probability sample. But let's say they came and then they use random approach, and then eventually they pick the people. That is a probability sampling. Okay, good. So under probability sampling, we can talk of a word. We have is based on random, but this randomness, we can get something we call simple random sampling. Random, okay, random, okay, simple random, okay. That's a simple random sampling. Random sampling. We can get something we call stratified. Okay, stratified, random, stratified, random, okay, random sampling, okay, random sampling, okay, and then we can also get something we call systematic random, okay, random sampling, okay. All right, and then we can even get cluster sampling. Okay, all these ones that I've mentioned here, there is an element of probability in it. Okay, then when it comes to non-probability sampling, we can get something we call the convenience. Okay, convenience sampling. Okay, you just sample them because they were close to you. All right, and then we can also get something like a purposeful. Okay, convenience is still it's a type of purposeful sampling. Okay, so purposeful or purposive. Okay, purposive sampling. Okay, all right, and then we can also get something like quota. Okay, so quota sampling. These are various forms of sampling. Okay, so sampling. All right, and then we have the non-probability sampling. So we're going to take them one by one, and then we'll talk about them. Okay. So let's start with one here. Let's start with random. Let's start with random. Simple random sampling. Simple random. Okay. Random sampling. Okay, great. Now, when it comes to simple random, this is the most idealistic form of random sampling. This one, when we talk of proper random sample where everybody has equal probability of being picked, okay, this is this one. Okay, so the question I'm asking you is that when do we use it? When do we use simple random sampling? When do we use simple random sampling? Yes. When do we use simple random sampling? Yes. When do we use it?
Okay. So, sir,
When,
please,
yes, please.
when the researcher has high confidence about the research, about the participants.
Okay, has high what?
Confidence.
What does it mean, confidence? When you say confident, what does it mean?
When the researcher knows that the participants will agree to the research or will agree to the study.
When the researcher knows that the participants will agree to the research. I don't really get what you mean, trust me. Come again, can you refine it very well? I don't seem to get the point you are trying to make. When you use simple random sampling, when do we do that?
Hello, sir.
Yes, please.
Can we also say that with a simple random sampling, when maybe a researcher thinks that whether he uses mass sampling or simple, he will still get the same results.
Okay. All right. Okay, great. When he uses them, then get the same results. Okay.
Yes, he uses it over and over, and then you have gotten the same result. So he thinks that using the simple random will probably be the best one to use.
Okay. All right. Honestly, when you come to the simple random sampling, the simple random sampling, that is the ideal one. That is the ideal one, whereby in fact, every member, when we talk of where every member of the word, every member of the pop has that's the most ideal, okay, whereby the most ideal one, okay, most ideal, okay, for every member, okay, every member of the pop, okay, for every member of the population to have equal chance, okay, to be picked. All right, that one, like it is free from where? It is absolutely
Non-bias.
free from bias. Okay, absolutely free from bias. And then when you do the simple random sampling, okay, the population, okay, will adequate. We expect that the sample you will get, the sample will represent, let me use adequate, will adequately, okay, represent the word, represent, will adequately represent the population. Okay, so that is the baseline. So if you want the sample to adequately, okay, represent the population, then you are thinking of what? Random sample. Because in this case, it is actually free from what? Bias. Okay, that each individual in the population has equal probability of being picked. Okay, and then when you sample, random sample, when you finish, we expect the sample to adequately reflect the population. What it means here is that, if let me go and draw something small here. Okay, so let's say if I draw something like this, let's say I have population here, and then I have male, female, okay, male, female, like that, okay, like that. It's female here, female, and then male, okay, like that. Now, let's say if I'm going to sample, let's say 5 people from this population, we expect that if I should use random sampling, okay, and then from this population, I'm expecting to get 2 males and what? and 3 females. Okay, 3 females. Because in this population, the total number of males are 4, the females are 6. So with this one, so this is my pop, okay, and this is my my sample. So the sample should adequately reflect the words, or represent the population as possible. Please, are you with me? Okay, please, are you with me? Hello? Hello?
Yes, we are here, but
yes, please, we are here.
Do you get my simple random sampling? Okay, so we
yes,
do
sir.
simple random sampling. One of the ways we do simple random sampling is that I can do more something like lottery. Okay, so we can put, let's say, in a class of 50 students, and I want to dash somebody. Maybe 50 cities at random. What can I do? I can just give everybody in the class can write a number on it, and then we'll do a draw. Everybody write your number, and then we'll put it in a container. All right, and then we'll just mix it up, and then eventually I will look at it, and then I'll just dip my hand into the container, and I'll pick one number up. In that case, everybody in there had probability of being picked. Okay, so that is simple random sampling. Okay, each person there has probability of being picked. So in that case, simple random sampling becomes what ideal to do it. Okay, are you with me? But we have, okay, so simple random sample, we know it is the best, it is free of bias, every individual has equal probability of being picked, and then when we get the population, we expect the population, when we get a sample, we expect the sample to adequately represent the population as possible. Okay, that is what we know about simple random sample. All right, but occasionally, you can get certain instance. Let's take it this way. Let's take it this way here. Now look at what I'm going to do here. All right, let's see. Let me try and increase this one even a little bit. Okay, let me try this. Okay, this. Okay, so that's the female population in the class. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so let me convert this one into male. Okay. All right, so this is 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so let me convert this one into male. Okay, so now my males are, okay, so let me add another male here, another male here. So now in this population is 20 individuals. In these 20 individuals, female is equal to what? Female is equal to 12, and male is equal to what? Male is equal to 8. All right, great. Now you are going to, let's see something here. Let's see something here. So ideal thing is the word for the probability sampling. The most ideal one is what? Is simple random sampling. Okay, great. But in some cases, let's say you want to test drugs. Okay, now look at what I'm going to do now. Right now, I'm going to pick people randomly. Okay, for this, so let's say this sample here, perfect. Now I'm going to pick people randomly from this group. Now I still, Kwame in my hand. When I do, I pick the first person, female. I'm picking 5 people from the group. Then I pick another person, female. I pick another person, female. I pick another person, female. Again, pick another person, female.
So why?
No, it's not random sampling I'm conducting. Kwame, so this is Kwame's sample, okay?
Wait, you man.
It's not me. The females here too, they have equal probability of being picked. So
Yes.
yeah, so this is sample A and this is sample B. Now, sample B here. Let me call Kwame sample. This is Kwame sample here. All right. Now, let's take it this way that it is a drug you want to test. And the drug you want to test, you want the test such a way that you want to see the effects of the drug on male as well as female. Okay.
Hello, sir.
Yes, please.
Then that means the sampling that you pick is biased, Jose.
It's not, but what the sampling approach wasn't biased.
It wasn't biased.
It wasn't biased. I put the numbers in a container and then I picked it randomly. And when I picked number 1, Rita, number 2, no, I picked that number 20, Angela, number 6, okay, Charity, number 8, I picked number 8, number 2, I picked number 3, I picked number 3, Lizzie. So the sampling that I did wasn't biased. The people wrote numbers, and my hand, when it went into the box, you know, Kwame and my sickness, the sickness also showed on my hand, even though I didn't look into the port or the bag where the number was placed. But my hand picked the numbers, and the people that I picked, they all happened to be the ladies. Okay, so the sampling approach wasn't biased. Okay, but the truth of the matter is that it didn't adequately reflect the population. Do you get the argument here?
Yes.
Yes. Okay. So ideally, we expect simple random sampling. Okay. That is what we expect. We expect simple random sampling. That's the gold standard. Everybody has equal probability of being picked and stuff like that. Okay, good. So in this case, okay, so no bias, there is no error in it. Okay, or even if there is an error, you even define, you can even calculate the error and everything like that. But when we pick the thing, okay, when we draw it, we realize that, yeah, the population that I had didn't adequately represent my sample. Are you with me? Okay, the sample I had didn't adequately reflect my population, because this one is trying to tell me that everybody in the population, they are all girls. Meanwhile, the girls are what? They are 12. They are about 60% girls and 40%. Okay. So in this particular instance, what sort of sampling will you what sort of sampling approach that you will conduct? What sampling approach would you conduct in a situation? Let's take it this way, that we want to see that the boys and the girls, which of them is performing better. But the school is so large, the population of about 1,000 students or about 2,000 students from KG to JSS 3. Okay, there are 2,000 students in the class. So if we are saying that we are going to conduct random sample, okay, yes, we can do it, all right? Because in random sampling like this, do you know what? In random sampling, what we do is that, first of all, what we do is that you, the researcher, okay, you have to estimate more or less your level of confidence in the data, okay, and then something you can even specify the error. You can even calculate your error. Okay, that's one thing about what probability sampling. Okay, that, oh, this is the error I can make, this is the level of confidence, okay, in my data set. Okay, you can do that. That's one of the key things about probability sampling. Okay, one of the key things about probability sampling, okay, let me put it here, is that probability sampling. Okay, good. Okay, where did I write it to? Okay, here. All right. So for the probability sampling, you can even, we call something confidence word, confidence level. You have to know your confidence level, as well as the word, maybe possible error. You can even estimate your possible error. Possible, okay, error, and stuff like that. That's one thing about the sample. But for this side, I'll throw more light on it as we progress. The confidence level and then the possible error stuff. Okay, I will throw more light on it. But this is the situation. So here you see, so sometimes even though simple random sampling is the ideal thing to do, but in some situation it is not the best thing to do. Okay, please, do you understand what I'm saying? From what I've done here, okay, looking at this population, look at my population here. My first sample, when the sampling was conducted by let's say one member of the class, it's when the sampling was conducted by James. Okay, when sample was conducted by James had perfect 40% male, 60% female, perfect. When Kwame conducted sample, I had what? I had 5 where all of them are females. Okay, so you see that in what instances, okay, the sample like this, see the moment I did now, one of you told me that it's biased. It's not biased. They wrote numbers, but I picked the numbers, and then I want to give somebody in the class. I want to give 5 people in the class money to go and buy food. Now, if I just call people in the class or just give it to people sitting in front of the class, I'm being biased. So, and people even after the class, you know, people will even begin to throw tantrum that I have favorites in the class. No. What about we all write the number and we put the number in the container? Everybody will understand that. Oh, they saw that we all put the number there. Everybody was, oh, you're lucky. Those is the lucky ones. People were just lucky, and then they have it. Okay, good. But in this case, in a situation, let's take it this way, that I want to see whether the boys and then the girls. Okay, all right. If I want a study, all right. So here, if it is something I'm dashing out to the class, and then I picked this one randomly, there's nothing wrong with it. Okay, they wrote a number and I picked it and I gave the money out. There's nothing wrong with it. But what about if I want to conduct a study, and the study is such a way that I want to account for the divisions in the population? Have you seen what I just said right now? So if I want to account for the divisions within the population, I can't do simple random sampling, because okay, so here let me go to another slide. So let's take it. So if let me copy here and take it to there. Okay, let me bring it here. Now, from this sample that I've done so far, okay, you can see that when I do simple random sampling, it could happen that I can even pick another person can pick a let's say third person. Let me take another person here. Let's say another person also does the sample from the group again, like that. Let's take it this way, that Abdullah did a sample from the group, and Abdullah had male, 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 and female, like this. You see, so something like this. Now, Abdullah picked it randomly. All right, and in his random sample, when he picked that he was going to give money to the class, he picked the 5 people that he picked. 4 of them are males and only 1 female. It was random. Okay, good. Now, so let's see something here. Now, if we do this, so you can see that depending on the type of question I want to answer, if I want to carry out a study whereby I want to account, let's say my study is such a way that I want to account for the structure or divisions. Okay, divisions within the word. Divisions within the population, within the what? The population, you can see that I can't use simple random sampling. Please, do you understand what I'm saying? If the purpose of the study is to account, if the purpose of the study is to account for the various strata, divisions within the population, okay, maybe the study is such a way that I want to compare the males and the females. I can't actually sample this one using random sampling. Even though the random sampling is the ideal thing to do, but in this particular situation, you've realized that if I want to account for the divisions, the sections, okay, let me even use sections here, okay, the sections within the population, I can't use random sampling because it's possible that I can pick all my first 3 samples, or my first 5 samples, and all of them can be even males. I can pick all my 5 samples and all of them will be females. Okay, so in a situation like that, what do we do then? Okay, so then, which means that even though random sampling is the gold standard, I will think of using something we call what? Stratified sampling. Okay, so in stratified random, okay, so we have simple random sampling. Okay, simple random sampling is the gold standard, but whereby I want to account, okay, whereby I want to account for the various divisions, the various strata, the various sections within the population, I can't use what? Simple random sampling. I have to do what? Stratified random sampling. Please, do you understand what I'm saying? So in this stratified random sampling, do you know what I'm going to do? What I would do is that, so here, you do this method in order to, you do this stratified random sampling so that you will be able to account. Here, the research question is demanding that I account for various divisions in the population. Okay, so I'm not just going to pick the people just simple randomly. No, I'm going to I'll block it first, okay, before I will do it. Okay, so in this particular case, what I will, let's say I will have a drug. Okay, I want to test the drugs on women. Okay, all right. Ideally, you know, this is of course for the women. Kwame will be assigned to that. Okay, so that's my special area. Okay, my PhD was on womenology, so I will be assigned to do that particular study. Now, when I do that, look at that. The women. You see, we are talking about females. Now, even for the females, the drugs, I have to first of all find out people in different ages, maybe people below the adolescent age, people maybe before menstrual age, all right? And then people who are pregnant, all right? Because there are some drugs, if you're a medical doctor and you are administering the drugs, you have to ask the person whether you are pregnant or not, which is not offensive because, you know, some drugs, okay, even some of these dewormer that people take, some of the dewormer, we have to ask the person whether you are pregnant or not, because some of the drugs can cross the blood, the placenta barrier, okay? So because the drug can cross the placenta barrier to the fetus, okay, we need to be particularly careful when we are administering them. So even when I'm going to test the drug, I have to stratify that maybe even for the females, if I'm going to test drugs, I want to know what will it do to kids, maybe toddler, okay, the toddler, all right, maybe people in the what, in the between the below between let's say 5 to let's say 12 years, or maybe let me take it 5 to 11. Maybe 5 to 10. Right now, the menstrual age has come down a little bit. So 5 to 10. And then maybe people in the adolescent age, okay, people in the adolescent, okay, the adolescent age, and then the women, maybe adult women, the adult women like that. And even the adult women, I have to see whether the person, those who are expectant, the pregnant, okay, the expectant women, okay, all right. So even though the drug I'm going to test, I want to account for the various strata within the population. So in this case, I can't use random sampling, because if I use random sampling, I can actually pick all the women in the box, and then I'll pick it, and I can pick all babies throughout. Okay, but the research is such a way that, okay, if the research want to account for the various divisions and the various sections or the various strata within the population, simple random sampling will not be ideal in this case. I have to do what? Stratified sampling or block sampling, more or less. So what I would do is that, first of all, in this particular case, okay, what I would do is that, okay, so let me draw here. Before I do the sampling, I want to account for the various strata within the population. So I'll, first of all, the females are what? The females are, let's say 200, let's say in a 2,000 people, the females, let's say, okay, let's assume I'm going to use adult. So the 2,000 people, the females, so that would be 1,200 here, 1,200 females, and the males are where? 800. Okay, like this. Now, so I'm going to sample 200 people for the research. Okay, so I'm going to, so let's say these are adult population. Let's assume that this is the adult population in a Cape Coast town. Okay, the adult population in Cape Coast town, let's say in Kotokraba, okay, the population is what? Is 2,000. Of this population, that is 2,000, men 800, women 1,200. Now I'm going to conduct a study on a particular drug. Okay, I'm going to conduct a study, or maybe I'm going to conduct a study on how, on the population, to see how people maybe respond to stress, something. But when I do that, after that, I want to see how men and women will respond as well. Okay, so in this particular case, if I say I'm going to do random sampling of the 200, you can pick the people randomly. Okay, simple random sampling, and everybody you will pick, it's possible that the 50 you will pick, maybe even the first 50 you will pick, could all be males. It's possible. It's random. Okay, simple random. So in this case, I'm going to do stratified sampling. And for me to do stratified sampling, what am I going to do? So first of all, I will block the population into the male, and here within the what? Within the female, I will sample. So I'm going to take 200 people. So within this female, I'll sample 120, and then within the male, I'll sample 80. Okay, so something of this nature is called stratified random sampling. Okay, so you do stratified random sampling in order to account for the various strata or the various divisions within the population. So if you want to do that, you can't use simple random sampling. This one, stratified random sampling, will be ideal. Okay, so anytime you want to conduct a study whereby you want to account for the various strata or the various divisions in the population, then it is ideal to use what? To use stratified random sampling. Okay, are we clear with that? So in this case,
if I get you right, does it mean that before you have the stratified stratified random sampling for the various divisions, are you going to do simple random sampling for the various divisions before you do the stratified sampling?
So here, I'll first of all block them into the male and female. So first of all, so the fact that I've divided into two, so male separate, then within each of them, I will pick the individuals randomly.
So you stratify before you sample.
Random sampling.
Yes, so I'll classify into male and female. Then I will allow all the males to write their number. So you can see that when I finish, it is still reflecting the population. You can see that it is still reflecting the population. When I finish, it will still reflecting the population. Are you with me? When I finish it, okay, it is still reflecting the population. Says that 60% female, 40% males. So I want a situation that I want to account at the end of my studies. I want to account for the word, for the structure, the groups within the word, the subgroups within the population. Okay, I want to account for the word, the groups. Okay, those groups within the population, the structure, the division, the sections within the population. So before I start, the first thing I will do is that I will divide I will stratify. Okay, I will block the population into what? Into male and female, and each of them I will sample from each of the groups. All right. So first of all, you stratify it first. You divide into two, male side, female side. But after I have done that, then within this one, I will do random sampling here. I will do random sampling here. Okay. So I'll block it, and then I will allow all the females to write their number. I'll put all the females in one container. Then I'll pick them. Then I will put all the males in one container, their names, and then I'll pick them randomly. Okay, so in a situation like this, this is what we described as what? Stratified random sampling. Okay, please, do you understand? Any confusion? Any confusion? Any confusion?
Hello,
Is
sir.
it clear? Yes, please.
Sir, okay. In the picking, how are you going to pick from the?
Yeah.
From
So
the
what I said is that I would divide into. So let's say in this class, so what I will do is that I'll put I know the entire population. Have you seen it? So I know the entire population. So what I will do is that I'll block the females, block the males. Okay, so all the males on one side, all the females on one side. All right. And then I will do what? So after I've blocked the two, males block, female block, then within each of them, I can ask people to write a number for me, like the lottery. Okay, I will ask people to write numbers for me, and then I will pick each one. In each group, I will do random sampling in each group. So when I come here, I'll do random sampling, simple random sampling here. I'll do random sampling here. Okay.
It's like that. Let me come in here again. Like we know that the females are let's say they are 12 and the males are 8. So you can see that
let's take live side. Let's take that the females are 1,200 and then the males are 800. And
so,
I want to
you can see that the females are more than the males. So in the picking, when you pick one from the females, will you also pick one from the males?
It means you are not paying attention. Look at my sample here. This is my sample here. Have you seen my sample here? You see that I've done, so I'm picking 200 people. All right. Okay. Are you there? Yes. Hello? Are you with me? I am picking 200 people. Okay. Now, the 200 people that I am picking, I'm going to pick 120 from the females and I'll pick 80 from the males so that I will adequately reflect the population. Are you with me now?
Yes, I get you.
So when I'm picking, I'll pick in such a way that I'll be able to reflect adequately. Okay, I'll be able to reflect the population adequately. In the population, there is 60% female. So females here. So at the end of the day, when I finish, the female population should be 60%, and then the male population should be 40%. So it doesn't matter whether I pick this and pick that. No, what it matters is that when I block this one, of this 1,200, okay, I'll pick the females here. I'll pick 120 there, and then the males here, I'll pick 80. Okay, randomly. I'll pick females. I'll pick them randomly. Okay, and then I'll pick the word. I'll pick the the males randomly. Please, are you with me?
Yes, sir. Thank you, sir.
Okay, great. But okay, so my question is this. Okay, so all right. Okay, so let me give a particular instance whereby this one is very important. Let's take it this way, that you want to test drugs in Ghana. You see, you can't just come to southern part of Ghana and come and test the drug. All right, you can't. Okay, especially in this festive season, people have moved home and stuff like that. If you come and test the drug just in southern part of Ghana, do you know what you do? Look at the people in the northern part of Ghana. If you look at the Abudus, the Sedus, the Harunas, they are thick, tall, massive. If you look at the Farfetch, for instance, they are very thick. Okay, like that. Now come to south here. Okay, south here, you see a lot of Shatingos here. All right. So if you go and test the drug, okay, in just northern part of Ghana, okay, so let's say Ghana here, and then you just go and test the drug, okay, in the northern part of Ghana, and then you say, oh, this drug, you know, the people in Ghana, they have to take just 20 grams for it to work. Meanwhile, when you were testing the drugs, you tested it just in the northern part of Ghana here, okay, you tested it here. And you know, northern part of Ghana, especially the upper east region like that, you can see the folks here, they are very thick, huge and tall, compared to those of us here, the Shatingos that we have here, right? So in this case like that, you see, you're making a lot of this. So here, you have to account for the various geography, okay? So that we call it what? Geographical stratification, okay? So you are, okay, you actually stratify in terms of space. Are you with me? Okay, so that's a classic example. Okay, you stratify it in terms of what? In terms of space. All right, you have to block. If it's something that you are going to, even if you want to do even perception of people in Ghana, you can't just come to just Cape Coast and then just say that, oh, Cape Coast, there's no problem in Ghana at all. Everybody, they are nice schools in Cape Coast. In Ghana, all the schools in Cape Coast are very nice, this and this. And that might not be, if you come to just the southern part of Cape Coast here, whereby we have most of the SS schools in Ghana, all located in the, let's say, world resource schools in Ghana, like especially the missionary schools, okay? They are all based in southern part of Ghana. You can't just come here and just sample just few schools in Cape Coast here and use it to represent the whole of Ghana. No, you're making very wrong assumptions. Okay, even if you just come to Cape Coast and just use Cape Coast and sample Cape Coast, because just move from Cape Coast to just Asimfosu, okay, onwards. You can't tell me that the Asimfosu schools, those non-missionary schools in maybe Asimfosu and stuff like that, they are equally resourced like those missionary schools in Cape Coast. Okay, so in this case, you need to do what? You need to do geographical stratification. So you block the place geographically. So you have to pick sample in the north. So maybe you sample this part of the northern Ghana, sample this here, sample here like that, sample here like that, sample here like that, sample here like that, sample here like that. Okay, so that is what, let's say, okay, let me go and bring Ghana map so that you get an idea of what I'm talking about. Let me get Ghana map here. Okay, Ghana map. Okay, Ghana map. All right, so that you get a rough idea of what I want to. Okay, let's say something like, let's say one beautiful map here. Okay, so that you have idea of what I'm talking about. So let's say something like this. All right, good. Now I have Ghana map on my screen, like this. Okay, something like this. Now, let's take it this way that you want to test drugs, how drug is working in Ghana. And then you came here now, you went to Boliga, okay? You went to Boliga, all right? And then pick some people here, all right, like that, and use it to test the drug. Now, people in Boliga, as we know, they are very huge, very massive people, okay? They eat bankun, you know, like that. And so they are very huge, okay, thick people. Now, if you take the drug here, you will kill all of us. because most of us we are not as huge and massive like people in Bolga. Do you understand that? So for you to get the population adequately, you can't just make, but if you just do simple random sampling of the place, you just pick Bolga and you just go and pick the data. But if you want to account for the various groups in the population, you need to sample here, maybe sample there, like that here, sample somewhere here like that, all right, sample somewhere here like that, sample somewhere here like that, sample somewhere here like that. In that case, you will adequately represent the population. And even when you are sampling, you can see that North is sparsely populated. So you see, you need to sample more people in the southern part of Ghana than in the northern part of Ghana, because the population in the north is not so huge as compared. The Accra may be small in terms of size, but you can see a lot of people are in Accra compared to any other part of Ghana. Okay, so for you to adequately account for the various strata within the population, we have to do what? We need to do something we call geographical stratification. So you block the places geographically. But when you go in there, you need to sample the individuals here randomly. Okay, you need to sample the individuals randomly. All right. If even the individual, if I want to account for various groups within the individuals, maybe even the ladies, even if I want to account for the various groups within the individuals, okay, I can still go forward. I can still go and then let's take it this way. Let's say rows. Okay, so let's say, come here, let me do something here. Okay, let's say 2. Okay, let's say okay, like that. I can still do this one whereby I will account for various words. Let's even the ladies have to know, or if it is females, and I'm testing on drugs, and I know drugs, children, maybe I can say that babies, okay, babies, or maybe children below what, maybe under 5 years, okay, I can say between 5 and between 5 to 10, okay, maybe 11 to 15. You know, most of the drugs we've been taking, all right, so 11 to 15, and maybe 16, then maybe greater than 15 here. All right, something like that. And if we can even add people who are what? Who are expectant. Okay, in case some people are pregnant, we need to account for them as well, so that we will know. So here you see that what I'm doing here, I'm accounting for the various groups. Okay, so you see, when you buy drugs that you are taking, if you read it, they will tell you the age for even acetaminophen. They will tell you the age for children to take it. Okay, the age for children to take it, different ages. They will tell you that, oh, people who are 10 years old should take this one. People who are this age should take this one. Sometimes they will even, if they don't use age, they will use weight. That, oh, people with this weight should take this. People with this one should take that. So that you account for the various strata within the population. Okay, good. Please, are you there? Are you there? Now, the question I want to ask is this one. Okay, so right now, the main advantage of this one is that it helps us to what? To account for the what? For the various groups within the population. Now, what will be the shortcoming? What are the disadvantages of this type of sampling? What are the disadvantages? Yes, what are the disadvantages? If I may ask you, what are the disadvantages of what? If you were to do simple random sampling, you are going. But what are the disadvantages? Let's see, what are the disadvantages of what are the disadvantages of stratified random sampling? What are the disadvantages? Yes. Can somebody help me? What are the disadvantages?
Yes, Doc.
Yes, please.
I think it will be time consuming.
Good. It will be time consuming. That's excellent. All right. Please, do you believe that? Excellent. That's excellent point. Okay. It will be time consuming. Okay. And what's the reason that it's going to be time consuming? Why is it going to be time consuming?
Because of the geographical location, the distance.
Yes, so because you want to account for the various factor, okay, I use this geographical one as an instance, okay, all right. So this one, okay, I use the geographical location as an instance, but whether so this is geographical level, this one is non-geographical, all right. Okay. So please mute your mic. There's much echo in the recording, please. So in this case, like that is for stratify random sampling. Okay, what is it is going to be? What it's going to be time and where time consuming. That one there you won't like time consuming. Okay, time consuming. All right, even blocking it. Okay, my PhD work. I came to Ghana to do the sampling, and I was doing sampling across the whole of Southern Ghana because I wanted to get the information across the genetic nature of insecticide resistance, of the resistance to the mosquito spray. Okay, and I sampled almost every section across Southern Ghana. So I'll pick the place here, and then various structure within the across the Southern Ghana. So I moved right from, I didn't go to the northern part here, but from Elibo all the way to Inchi and stuff like that. Inchi and Asankogo, I sampled all of them from the new town here, Western up to Aflao. I went to almost every point there, so I sampled various points within, okay? So that I can account for the various structure within the population. So that's time consuming. Okay. Yeah. What else again? Apart from being time consuming, what else again?
Cost effective.
It's
the
not
cost involved.
The cost. Yeah.
Cost
so time.
involved.
So it is costly. That's good. I mean, blocking it is costly. What else again?
Yeah, Doc.
What else again?
I think there will be
yes,
some
please.
kind of complexity in analyzing the data that will be collected from these samples.
Of course. I mean, that's very true. For instance, if I'm just analyzing male and female, I'm done. If I'm just analyzing just 2 layers like that, let's take it this way, that women who are pregnant and women who are not pregnant. That's very simple to do. The more layers you introduce, the more complex the analysis becomes. Okay, so in terms of the analysis, the more layers, the more groups you assign to it, the more complex the analysis actually becomes. So in terms of what, the definition, okay, the complexity of the analysis, okay, that one is something we cannot overlook. Okay, so the more layers, okay, let's take it this way. Instead of just making male and female, I'm just going extra mile to see even the females. What are those in 5, below 5, between 10 and 11 to 15, and all to maybe even I can add layers. Okay, women who are expectant, those in monopause, like a whole lot. So the more layers you add, the more complex. Okay, the more complex the analysis. Okay, becomes. Okay, the more complex. Okay, the analysis becomes. Okay, good. And then there, you see, before you can even do that, before you can do this grouping, all right, which means that you should have what? You should have prior knowledge. You should have prior knowledge of the word, you should have prior knowledge of the population. All right, you should have prior knowledge of the population. All right, before you can do this one, before you can use stratified sampling, if you don't have the prior knowledge of the population, you can't at all. So which means that I should have fair idea of the knowledge. I have to know the knowledge of the population, because remember that anytime I'm sampling, you see, I have to sample such a way that because I have prior knowledge that the people in the population are what? They are 20,000, with males being they are 2,000, with males being 800 and females being that is a female being 1,200. Okay, so in this particular case, then I can, because you have to get this knowledge, the prior knowledge of the population before you can do it. Okay, so it is, and getting that knowledge is can it itself can even cost you. All right, so you should get prior knowledge of the everybody, what is there, so that you will know how much you take from the males and how much you take from the females for your to make up your sample. Okay, so the stratified random sampling, okay, the stratified random sampling, it is ideal when you want to account for the various strata within the population. Okay, that is that's a gold standard to use. But the downside of it is that it is where just even grouping them, creating the various divisions or creating the various strata can be what? Can be time consuming and costly. And on top of that, before you can do that, you need what? You need to get some sort of prior knowledge. You need to get prior knowledge about what sort of what? The prior knowledge about the various of the entire population in terms of the various groups. For instance, if you want to do it by the gender, you should know how many of them are females, how many of them are males. If you want to do by age, like in the case of female like that, I want to do it in terms of age. How many people are below 5? How many people are between 5 and 10? How many people are between 11 and 15? How many people are more than 5? How many people are expectant? How many people are in the menopause? That sort of thing. You have to take all this information, and getting this information alone, the time and then the resources and then the effort you will take into it to get that is quite a lot. Okay, all right. So, but sometimes that is the nature of the study that you are, or the analysis or the type of research you are conducting. That is the only approach that you need to conduct. Okay, you need to adopt. Okay, so we have instances whereby simple random sampling is not possible, and for that matter, we need to do what? We need to adopt another sampling strategy. And one of the strategies that we can adopt is what? Is the stratified random sampling. And in stratified random sampling, the advantage is that it accounts for the various strata. It provides information on the what? On the various strata within the what? The population. All right. So it provides some sort of information, and then, for instance, what I did here, I've done my stratification based on what? On the geography. So this one, we can talk about that as well, geographical stratification. Okay, and then apart from that, it also ensures that, I think I can write that. Okay, so another the advantage here is that okay, so let me take this one here. Okay, let me put it here. Let me put my, okay, let me put, all right. So the advantage here is that okay, advantage here is that, okay, okay, great. So the advantage here is that, okay, so it makes sure that what? The population, the sample, okay, the sample adequately, okay, the sample adequately represents the what? The population. That's one thing for sure. Okay, it ensures that the sample adequately represents the population in terms of even its composition as well. Okay, and then well, apart from represent, what did I write? Okay, yeah, you understand this. And then the next one is that apart from that, it also helps us to work in terms of it increase some sort of provides what provide info on the word, on the various strata, okay, or groups, okay. Groups, okay, within the word, within the population, all right, various groups within the population. And then maybe the third points that I will talk about is that some sort of precision and accuracy. It actually increases accuracy a little bit. Okay, in a sense that, for instance, let's take it this way that if I'm doing simple random sampling, if I use this size here so that okay, good. If I'm doing simple random sampling and then you take the first, you pick it and then randomly you pick males throughout, obviously you can't really conduct the studies very well. Okay, so the advantage is that it adequately represents the population. It ensures that it provides information on the various stratum of the population, and then it enhances the word in terms if you are doing some sort of analysis in the population. Okay, all right. It actually increase some sort of what accuracy. Okay, accuracy and word. So increase accuracy and word and precision. Okay, precision. All right, it increases because if you do simple random sampling and then you just pick this and then you test it, at the end of the day, you will not be able to get it. So for simple random sampling, it's actually assume the population is what is homogeneous. Okay, it says that its population is homogeneous. Okay, but in this case, because there are various groups in the population and they will be accounted for, okay, it's actually increased the precision or the accuracy of the data, okay, of the data that you acquire. All right, good. To increase the accuracy of the data you are going to acquire. And then, as we said, the sample will adequately represent the population. Okay, adequate. Okay, represents the population, and then to also provide info on the various groups, and then it also ensures it enhances the accuracy or the precision of the data. Okay, good. Now let's see. Okay, so let's see in what situation, and then we talked about the downside. The downside is that you need to get information, prior knowledge, like you need to get information about population. In this case, our prior knowledge is we need to know that 2,000 with the males being this, with the females being that. We need to get that knowledge. We need to get the knowledge of the various groups. And then analysis becomes complex because once you begin to add layers, okay, the more complex the analysis becomes. And then it could be time consuming, okay, time consuming and costly in creating the structure. Okay, please, if you just write time consuming, if I ask this question in the exams and you just write just costly and time consuming like that, I won't mark you. You have to, in creating the structure, okay, creating these various groups, the various structure could be time consuming and costly. Please, any question for me before we move?
Yeah, adding up to the layers or creating more layers or adding up to the layers, can't it rather bring about errors along the line?
Whichever way you could get errors, but the thing is that when you are creating layers, okay, like for instance, if my analysis is based on just male and female, that's easy. to analyze. I'm only comparing male and female. Now, the moment I add another layer, that their income. So now look at now that what I'm doing to. I'm now analyzing females and their income, males and their income, compare the males and the females and their income. Have you seen it? So you see that the more layers you add, the more complex the analysis becomes. If it is just male and female in terms of their income, it is very easy. But the moment you start adding, now I have male and females. I didn't end there. Then if I'm comparing just the parameter of interest, maybe the food they eat, the quality of the food they eat. That's what now I have added in their income. So the income is going to influence. So I have to stratify based on income as well. Now I've added their age. I have to stratify based on age as well. Even the age, different categories of the ages need to. So the more layers you add, okay. In fact, that will make it more informative. Okay, you'll be able to acquire a lot of information, but the thing is that the analysis becomes very complex because you are adding more layers. The more parameters you put in there, okay, the more variables you put in there, the more complex the analysis becomes. Okay, whereby if I'm just comparing, let's say right now I'm just comparing male and female, the average money we make in a year. It's simple. I'm not factoring work. I'm not factoring anything. I'm not accounting for any structure. I just pick male, female, and then the amount of money we get. That's all. But the moment I start adding layers, various structure, like where the person stays, what type of work the person does, the person is married to, what's the background, what's the geographical area. Okay, people in the north, they get cheap food because the food there in the north are not expensive like in here. Our food here are very expensive because they transport it from the north. So the yam you are supposed to buy here, the north people will buy it for 20 cedis. They are selling it to us here 60 cedis and 70 cedis. So the moment we begin to factor layers, bringing where the person is living will determine how much money is going to spend, okay, and stuff like that. Because the same yam tuber that maybe Nimatu will buy it in the north for maybe 20 cedis, that same yam of tuber, Kwame will buy it here for 60 cedis. Okay, so you see, so all this one will affect our expenditure. So if I'm the more layers that I have to factor where the person is living. Okay, is the person married as well? Is the person that how many children is the person having? All these factors. Okay, so the more layers that I introduce, the more structure I create, the more complex the analysis is going to be. So the moment I start bringing number of children, now the question will be how many children? Because if you have only one child, if you have two, okay, you be spending more. If you have three, all those complexities. Okay, so the more layers or the more structure you create for the data, the analysis actually becomes more complex. Okay, just that at the end of your analysis, you are likely to get more information. Okay, you are going to get more information, various groups and stuff like that. It's going to be informative, but the analysis will be complex. All right, great. So that is that for now. What about, there's another one. So right now we've done simple random sampling is gone. Okay, so let's say simple random sampling is gone, and then we've also done stratified random sampling. Okay, now we also mention of what we mentioned of systematic. Okay, if you look at what I wrote here, I also brought what systematic random sampling. Okay, what is systematic random sampling and when do we use it? So now the one we want to talk about is what systematic random sampling. Okay, systematic random sampling. Okay, sampling. All right, good. Okay, yes. When do we use it? When do we use systematic random sampling? Yeah. When do we use systematic random sampling? When do we use it? Systematic random sampling. What is it? What is it at all? When you talk of systematic random sampling, what is it? What is it at all? I don't understand. This is my first time of hearing that word. Yes. When you say systematic, what does it mean? Okay. Well, let me break it down to. When you say systematic, what does it mean? Yes. When you say systematic, what does it mean? When you say something is systematic, what does it mean? Yes. The gentleman. Yes. I want to hear.
It means it follows a certain regular order.
So, oh, okay, good. So when you say something is systematic, systematic means it follows follows, okay, regular, right? Regular order. Good. Nice. Okay, good. So here, what it means here is that, okay, now we know when we'll use all this. Here, in this case, when the population is homogeneous, we assume the population is homogeneous. When there are various strata within the population, there are various groups, we use the stratified sampling. And then there's another one we call systematic sampling. Okay, and one of the gentlemen here said that the word systematic means follow regular order. Okay, so the question is, what is systematic sampling? Now that our brother has thrown more light on it to know what something systematic means, what does it mean now? Yes, can one lady help me out? Yes, can one lady help me out? Yes. Can one lady help me out? Yes. 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 Can one lady help me out? Yes.
Using a sequential way to sample a population.
Okay, using a sequential way to sample a population. Okay, so some of the sequential way we can do is we can say that we are picking every. So let's take it. So that okay, good. So now we know that using sequential way, sequential way of where of sampling of selecting from a population. All right, good. Okay, nice. Now we believe that. Now my question is this: when at all do we use this one? When does it become necessary to use this one? When does it become necessary to use this one? Yes, when does it become necessary to use this one? When?
So can you say
when
when
does it
the
become
population is very large?
Yes. My ladies, you need this class, dear. This class, God, you need this class, and the ladies. So when the population is very large, when the population is very large, okay, when the population is very large, all right, and you want to take some individuals to form the samples, all right, the population is very large, and you want to take some individuals to form the samples. How do we do it? In this case, systematic random sampling is the best. Okay, are you there? Are you there? Are you there? So the population is very large. Let's take it this way that you are in the school. You want to do what? You want to sample. The school has a population of 1,000 people. Okay, and you want to do random sampling. How? Of let's say 200 people, or let's say 20 people. You want to do 20 people. All right. Yes. In this case, like if you are saying that you are going to pick, and let's take it this way, maybe I'm not even interested in the block that I'm going to block them. So what you can do is that, let's take it this way. You can pick the first number randomly. Okay, look at how we do that systematic one. So systematic one, what you do, let's take it this way that I want to sample, I want to go to Kotokraba and sample 20 people and talk to and administer questionnaire to them. Okay. Okay, so I go to Kotokraba market, okay, in Cape Coast here. And then when I get there, I want to get the word. I'm going to sample 20 people. All right. So I'll go to Kotokraba. So here you have to go with predefined objectives. You see, all the rules must be defined from the onset. So let's see what I'm going to do. So when I go to, let me see, let me draw. Okay, when I get to Kotokraba, so I go to Kotokraba market and then I'll go to find my central location in Kotokraba. You see, my central location is here. All right. Now I want to sample 20 people. And we know that Kotokraba has about 2,000 people in Kotokraba. Okay. I want to administer questionnaire about how the Christmas is going, the market women and then the market men. I want to just sample the people there and then talk to them about it. So if I go there, how would I? There are plenty of people. I just want to pick I want my sample size to just be only 20. All right. So now the question is, how would I pick them? How would I go about it? So in the systematic sample, you pick the first one randomly. And then you pick, so let's take it this way. Now I'm going to, I go to village. I'm Chrome village. I want to go and talk to 20 people, but I want it to be, random as possible. So when I go there, what I can do is that I can just choose, when I go there, I can just tend to take numbers and write maybe 1 to maybe 10 on those numbers. Okay, like that. Okay, and then I will throw the numbers up so that, and then so the number that I will throw them, I can write the numbers on some small woods distance, and I will throw them up like that. And then the direction where they will land is where I will choose, so that I will know where to start first. Did you get a point, right? So you can see that my starting point of the word, my starting point here, I've chosen my starting point randomly. Okay, so I will choose the first individual, my starting point. I will choose the first individual randomly. Okay, and after choosing the first individual randomly, then I will decide that I will pick I will count. Okay, I will count every, then I'll count like this. Let's see. Okay, let me put this one here. Then I will count that everywhere. So I will pick, so you pick the first person randomly, and then pick the nth person. All right. So I'll pick the first person randomly. Then I will decide that at every, I'll pick, if I'm dealing with 2,000 and I want just 20 people, I'll pick the first person randomly. Then I will decide that every 100 person. Okay, so 100. Okay, 100 person, right? So I'll pick the first person, every 100 person. Okay, I'll pick every 100 person, okay, to be part of mine. So I'll pick the first position randomly, all right, or the first person random. There are several ways you can go about it. In this place, if I go to a space, like a place, a village, I can choose to pick numbers, and then I'll write on the numbers. Then I'll throw the numbers up. And then the direction, that's one, the first number, I'll pick one. I will, let's say, pick one of the numbers randomly, okay? Or like I will pick one of the numbers randomly. Let's take it this way that I can choose to say that, okay, I'll put the numbers in a pot, okay, in a pot, and then I will pick one of them randomly. After that, I will throw all the numbers up in the sky and throw everything up. And I will decide that, okay, wherever this direction, the direction that the 3 will land, that is where I'll throw everything up randomly again. And then where the direction it will give me. So if the 3 pointed this way, I'll start from here. Okay. So you pick the first person randomly, and then the nth person will be picked afterward. So then I pick the first one, then I'll decide that after every 10 person, I'll pick every 10th, I'll pick every 100 person, or I'll pick every 50 person, like that. Okay, so I get my sample size. Okay, so this particular method is used when the population is what? It's very, very large. Okay, and then you want to, okay, when the population is very large, okay, and you want quick data on it. Okay, the best one to go about this way is to use the systematic random sampling. So you pick the first individual randomly, and then you do what? You will pick the next one in a particular order sequence. Okay, a particular order. That the nth number, you could decide 5th number, 10th number, 20th number, or 50th number, or the 100th number. Okay, all right, good. So what is the advantage of this one? What's the advantage of this approach? What is the advantage? What's the advantage
Can
here?
I ask you a question?
Please go ahead.
Okay, so with the systematic sampling, it means it's the first number that is done randomly.
Yes, please.
But the subsequent ones are done by counting.
But yes, so let's take it this way that we are in a stadium.
Yes.
We are in a stadium. We want to give we want to pick 20 people in a stadium, okay, to come, and then so if we go and then let's take it this way that we want some even distribution. We want it to be even. And you know that the tickets we're giving, okay, we're giving the ticket from, let's say, the stadium of, let's say, 5,000 individuals. So we decide that, okay, we want it so that wherever people are sitting, the seats are numbered all around. So we want it such a way that everything is going to be uniform. So we'll pick the first person randomly. Okay, so we decide, maybe we'll pick the first person, okay, randomly, all right? And then once we pick the first person, but we will define the criteria, you define it at the start of the experiment. Not that in the middle of the experiment that you decide that you are going, after you pick randomly, you will be picking 20. No, you define in the beginning of the experiment that, okay, I'll pick the first number randomly, and then the subsequent number, I'll pick it at maybe every 50th number that we'll pick it. So let's take it this way that I pick the first number randomly, which is, let's say, 10. Then after the 10, every 50th number from 10. So which that is going to be 50. When I count, okay, from 10, the 50, so it is going to be the 50th number from 10 is going to be that's a 61st number. Then I go to the 50th number from there as well, so plus 50. Then I'll pick that number. So after picking, let's say if I pick, let's say, let's say that I decided maybe beginning of the experiment, I decided that I'll pick the 5th number. So I go there, pick the 5th number. Let's say beginning of the experiment, I pick the 5th number. I'll pick the next one, 10th number. I'll pick the 15th number. Pick the word 20th number. So it will go like that. Is that clear?
Yes, please.
But the best thing is that there should be randomness in it. That is why you should try as much as possible to pick the first one randomly. Because let's say the first one, you don't have any control over it. So you pick the first one. If it is a scientific studies that you are doing, you are required that you pick the first number randomly, and then you count from the first number. That is the ideal thing to do. Okay, All right, you pick the first number randomly. You decide that, okay, after I pick the first number, then I'll count. After I pick the first individual, okay, I'll pick the fifth number. So then the next one will be 10th, the next one 15th, the next one. So you go in that order, okay? All right. So let's take it this way. That I said that like, when I meet once I pick the direction randomly, okay. When I pick this one, so the next person I will meet. So let's say I pick number 1. I pick let's say Angela. Then I'll count. So the fifth person I will meet. So let's take it this way that the fifth person I will meet. Okay. Let's say the fifth person I will meet. Let's take it this way. That so which means that I will skip Kwame, I will skip Dankwa, I will skip Aaron, I will skip Davidson, and then maybe the next person I'll pick will be Idrich. Okay, so it goes on in that manner. Okay, so what you do is that you define the criteria from the onset, and then you go strictly by them. Okay, but that's that I said that for scientific study, okay, proper systematic random sampling, okay, what you do is that you pick the first member randomly, and then you start picking the nth tail, okay, and in that sequential order. All right, good. And this particular sampling is done when the population is very large. When there's a large population, then we use this sampling method. Okay, good. Now my question is, what is the advantage of this method?
Doc, I have,
yes, please. What?
He said when the population is large, but if it's large and you don't know all of them, won't it be a difficulty? So I think it should be maybe large and maybe known or large and complete.
That is where that's where we are talking about advantage and disadvantage now.
Oh, okay.
Yeah. So what are the advantages? So let's talk about the advantages and then we'll come to disadvantages. What are the advantages?
Okay, sir.
Mm-hmm.
For the advantage, you don't need a complete list of participants before you can conduct the research.
Okay, so you don't necessarily need complete list of the applicants. That's good. Okay, so you don't necessarily need So maybe we can say that it's simple and easy to do, right?
Yes.
Okay, yes, maybe simple and easy to perform. Okay, it's simple because all that I need is that once I'm working, I've defined that I've defined it this way that as I work, I'm just sampling the first 5 cars that I will. So when I pick the first car, I will pick the next car. I will pick is the white. Is the 6th car. The next one I'll pick is the white. Is the 10th car or the 11th car. So you go in that order. Okay, that's good. Yes. Any other points, please?
It is also faster to do. I think time efficient.
Yeah. Good. So I will maybe good. I think I will add faster here. Simple. I will add it to the side as well. Fast. Yeah.
It is faster than specified.
Yes. That's true. Good. What else again?
Practical for large population.
Yes. There's one point I'm expecting to hear from you that nobody is talking about it.
So can you say it's less biased?
Yeah, less biased. Good. Less biased. But there's one point I want to before we come to this bias.
It is practical for large population.
Practical for large population. Okay. Well, I'll write it. Okay, practical. Okay, I'll write this one. Practical for large. Practical for large population. Good.
Or evenly spread.
Okay. That's what I was expecting. In terms of coverage, you can see that they're evenly spread. You see, it can show up like you almost everywhere. Okay, so like you are taking number in everywhere. So if it is 10, you started taking number almost everywhere. So yeah, so in terms of coverage, it ensures what? Even spread, okay? It can spread it like so in terms of So in terms of coverage, okay, coverage, it ensures what? Even, okay, it ensures even, okay, and an even what? And an even spread, okay, an even spread across the world, across the population, okay, all right, great. It's ensure even spread across the world, across the population, all right, good. And what else again? And then our brother also said that in terms of word, it says that it minimizes word bias, okay, all right. So in this case, because we define the terms before we started the population, it's also because the thing is fixed, all right, that it is systematic, which means that it actually it reduces any sort of bias, okay. So it minimizes, okay, it minimizes what? It minimizes bias. Okay, so that you won't come and tell me that we are taking people from the fifth, so the fifth, let's say fifth person. Okay, so when I take one, count five, the next fifth one, so that's going to be sixth. And you count the next one. So here you won't tell me that as you counted, and then you realize that, oh, that your family member, oh, this one there, the money you are going to give, you are going to dash the people money. Okay, now you realize that your family member is sitting at 13. Meanwhile, when you chose the number, it doesn't cover the you said 50, and it doesn't cover it. Okay, so it doesn't cover it, means you are going to know. Everybody will see that from the beginning of the study, you said you are going to pick 50. Okay, you are going to pick 60. Okay, so in this case, like that. Okay, so it goes on and on like that. Okay, so you define from the onset. Okay, and then so it minimizes bias. But you pick the person and say, look at that, that's my friend is here. So no. So bias is what is minimized. Okay, great. So it is fast, it's a simple, fast, easy to do. Okay, practically, it's practical for large population. Okay, and then in terms of coverage, it ensures what? It ensures an even spread across the population. All right, and it minimizes bias. Okay, all right, good. Now let's see the disadvantage.
Okay.
Let's see the disadvantage. Yes, please.
So please, in terms of the bias issue, can we say that there will be a bias in the starting point where the random pointing is done?
That one is not bias. If I did it randomly, then it's not bias. Okay, if I did it randomly, the starting point,
you know that like you are doing, we know you are doing it randomly, all right, but where you do the choosing, knowing where this person is standing.
No, so that is so. The moment you know where the person is standing, then you are wrong. Then on day one is bias. So that's why the first one. Let's take it this way. Let's take it this way. Where do we start? Let's say on the starting point. Let's say I have 200 people in the class. I'm going to pick 10 people. Okay. When I go, let's say I've written 1 to 10 on a number, on a paper. So which person should I pick first? All right. So the class is there. So I have everybody in the class. All right. So when I go there, the first thing I'm going to do is this. I've written 1 to 10 there on a piece of paper. Okay. So I have my numbers. So I'm going to start like this. Okay. Let me. So I go to the class. Okay. Before I start, I'll pick so let's say I'm going to pick my sample. So before I start, so the starting time, I'm going to take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And then, so I'll pick my starting point. I'm going to pick my starting point randomly from this number. Okay. Then after that, I said that after this, I will pick the rest of the number. Okay, in what? In fifth. Okay, the fifth number. Okay, in the sequence. Okay, so let's see what I'm going to do. So first one, so I go to the class. I have this, I can take piece of paper here, 1 to 10. Then I'll pick what? I'm going to pick this from 1 to 10 numbers. I'm going to pick out of this number. I want to see where I'm going to start. I'll pick from this number randomly. So let's say I throw this number, okay, or I shuffle it, okay, and then I pick, let's say, 7 as my starting point. That's the number I picked. So starting point is 7. I pick the 7 randomly. Okay, I pick the 7 randomly. Then 7 plus 5. 7 plus 5 will be what? 7 plus 5 will be 12. So I'll pick the 12th person. Okay. Then I'll pick the word plus 17. 17. I'll pick the 17th person. Then I'll pick the plus 5 again.
22.
20 what? 22nd, right? Oh,
22.
Then plus
22nd.
20. You see, the men are doing their things again. You, if I say something, they will say, so I mean, I won't say
22.
20 seconds. So we have the 23rd like that. Okay. So so like this, so you can see that, you see, after I pick this one randomly, now I'm following a particular, so plus 5 plus 5 plus
30 seconds is written 33rd. 30-second check.
30 seconds.
It's supposed to be ND.
It's the second.
ND, not
Oh,
RD.
second. Yeah, the virus, the main virus affected me. The main virus. So
one doctor down.
Is you. Okay, so like that. So you can see that from here onwards, you can see. So these are the, so I define the starting point. I pick one of these numbers randomly. So when I pick this number randomly, then I define that from that number plus 5, the next 5, the next 5, the next 5, the next 5, like that onward. So these are the numbers I'll be picking, okay, till I get my word. So I'll pick the person who is sitting on this one. I'll pick the next one who is this. I'll pick the next one like that, like that, like that. So this is how you conduct it. Okay, this is how you conduct it.
How the ladies are picking on you.
The word, oh, I forgive me. No, I
The
forgive
ladies are one doctor down.
Okay. All right. So here, what is the disadvantage here? What's the disadvantage here? Looking at what I've done here. So I did this one. So I was going to pick, let's say, 500 people there, and I'm going to pick 20. Okay. Let's say maybe 200. Okay, and then I decide this rule. Okay, or like that. Okay, or 100, and I decide this rule. Okay, I decide this rule that 100, and for me to get 100 people from the class, I say I'll pick one person randomly, and after that, when I pick the randomly to be plus 5, the fifth, it goes on and on. So I get everybody like that. Okay, then I'll get my 20 people for the class. Okay, so what's the disadvantage here? Now let's go to disadvantage. This disadvantage of years of where?
Can you say it's not flexible?
What does it mean it's not flexible? You say it's not flexible, what does it mean?
When the data mismatch or when the data changes.
In what sense? In what sense? Like, I want to know. When it changes, like where?
When the population increases.
Because this one, before you do it, one disadvantage here is that I think one of our colleagues said it in the beginning. One point here is that which means that before you do this one, you need to acquire the what? You need to get the entire list. You need to get the entire list of the population. You need to get the entire list of the population. So if it's a stadium with people in there, which means that if you are going to use the tickets of the people, you decide, oh, we'll pick the first tickets randomly, random number will be generated, and after that, maybe 5,000 people. So then we'll pick the plus maybe 100 or plus 200 from that random number. So one disadvantage here is that okay, you need to get the entire list. We need to get the entire list of the population before you do it. Okay, and that one, okay, that one could even be also could be hard to get. Is that not it? Okay, you need to get the entire list of the population, and after even getting the entire list of the population, which means that they have to be ordered. Okay, they have to be ordered. Like you need to, so you need to get the entire list, and then must be what, and then must be then, or the population must be ordered. All right, so you need to get this one before you start doing it. Wait, so I didn't get that your point that because one of the prerequisites of the systematic random sampling is the fact that you need to get the list of the population and even order them, must be ordered, okay, before you start it. Okay, all right. Which is even that's what the point that our brother said earlier on, and I said that is why there is this advantage. Okay, great. So what else again? Disadvantage of
Doc, according to him, let's say you have the entire list and then you order them.
Yes.
And then immediately you start, there is a different addition. Someone comes and add up to the list. It changes everything, so you have to start all over again. That's why you were saying that it is inflexible if the population changes.
Oh, so he is saying that if somebody comes to add to the list,
yes, then you have to start all over again.
Wow. If somebody comes to add to the list, you have to start all over again. But you produce the list before you start.
Yes, and then let's say there are 20 individuals in there. Let's say 200, and then you are choosing the 10th. Let's say the 10th number. So, which means if additionally 100 people come to add up to the list, you have to reshuffle everything again, and then, or you have to restart again, and then find a different n. Otherwise, the new 100 that I've added can't be selected.
No, but this is pretty much for all other sampling methods. Oh,
okay.
Because let's take it this way that I'm doing stratified sampling. All of a sudden, 100 girls have joined the class. It will change the entire population. So once people join, you have to start. Not what I'm saying. There's not this particular point wouldn't be strictly to systematic sampling alone, because the moment the population size, for the even this one we are doing here, the population size, the entire population must be known. There should be prior knowledge. So once the new addition comes into it, definitely whether it is stratified or systematic, once new people join, still we need to start because the population has changed. Okay, and you want to account for everything, so you still have to start. And I don't know, like my context is this something peculiar to just systematic sampling? Because I think even for stratified, if new people join the population, it will alter the composition, and you still need to start from the scratch. That's the point I'm trying to make here. Okay, all right. Okay, what else again?
Can I come in?
Yes, please come in.
To my understanding, once you have finished taking your sample or your population you want to work with, if you want to keep starting whenever the population changes, then you will not carry out the research. let's take it that. Let's take it that. Yes, I've taken a class of 30 students to work with, and then the next day there's new admission of 10 students. I'm not going to say that because new students came and joined, I am going to start all over again.
Yeah. Okay.
Yes, that's the point I want to make.
Yeah. So, and if you want to even do it again, it is no longer the same population. This is different population. Do you get a point? So I'm happy you brought this one. So the moment people add to the population, even if it's one person added, that's different population now that we are dealing with in terms of the size. So if 100 people, if the class size, I'm dealing with class size of let's say 60, and all of a sudden the other teacher in the class is not there. So my 60 holds, but if let's take it this way that the other teacher is traveling and decide, let's say I have A and B, and then A and B, my class that I'm handling, they are 60. And then the other class, they are 45. And I want to carry out a study in my class. And then the other teacher is traveling, so he asks his student to join my class. And then they add it to my class. Obviously, the population will become what? That now the population is different. Okay, the size is now different. So, and most of the time you will choose the nth term based on the size of the population. This nth term, the fifth term you choose it. So the nth value you choose is based on the size of the population that you choose it. So when new people join the population, of course, your nth term will change because your selection will be based on the size of the population. The size of the population will define how many people you are. Like we define your nth term, like the nth term you use to form your sample. That's the point I'm trying to make. Okay, any other disadvantage? So apart from this first one,
yes. Can we also say that it leads to loss of true randomness?
Yes.
In the sense that
yes, please.
In the sense that once the start point is chosen, the rest become deterministic.
That's excellent point. That's beautiful. Maybe that is the point our friend was just trying to make. Okay, that's the point. Okay. Because once you choose the fact, you see, it's always a starting point that you choose it randomly. You understand that? That one you use a simple random sample to choose the first individual. But once you choose the first individual, the other one follow a systematic manner. Do you understand that? So you are right to say that it is not truly random sampling, okay? Because the interval is fixed, okay? Is that not what you are trying to make here? Okay? So the point is it is only the what? So it is only the first individual, okay, that is what? That is selected randomly, okay? All right, but the subsequent ones, the subsequent ones are what? The subsequent selections is what? They are fixed.
Yes,
okay.
Fixed.
Maybe yes. that is why he's using the word it's not flexible. Okay, it's fixed. It's fixed, okay? It's fixed. It's fixed. All right. The moment we choose the first individual, what? Randomly, and then the subsequent one is fixed. And so, yes, I agree with you perfectly that it is not, so we can't say that the entire sampling is what? Is truly random. I think that, yes, I agree to this one. I agree to this point, yes. That's okay. We can't say that. The entire sampling is truly. Yeah, that's good. Yes, that's good. That's good. That's good. Any other points, please? Any other points, please? Okay, because it's only the first you will choose randomly. The subsequent one follow a fixed interval or a fixed pattern. Okay, right, great.
Can we say that it is cumbersome to be applied?
Yes, to some extent, yes. Okay.
It's rather flexible.
It is simple to do it, but
is it not flexible? Rather?
Is it not simple? Let's hear her point. Let's hear her point. Let's listen to it. Can you throw more light on it? Okay. So to you say it is what? Please come again. You say it is what? Come again.
It is cumbersome in its application, in the sense that once you don't follow you fail to follow the pattern, the sequence you are giving yourself, you can fill out something. The first one should be randomly selected, and then the subsequent one you are going to follow a sequence. Yes, that makes it a little. It's not simple as compared to the simple random sampling.
I think this one is simple.
So let me
this one, I think.
It's not simple.
So the reason
I think this one is simple.
He wants to say
no, there should be calculations. So
no, yes, because changing the sample size often requires reselecting the interval. So if you say 5 in addition to that, yes, so that is the interval. So changing the sample size would definitely require reselecting of the interval.
Reselection.
Yes. You know, there is always an addition of, like for example, the example you gave. We started with what, 7, then we added 5. Then we had 12, and we added 5 again. So you could see the interval, and that even makes it very simple.
Yeah, that's quite simple to do. That's very simple to do. Yes.
Doc.
But if you have
every doubt,
if you have
avoid every doubt in this way,
come
can
again.
You make it this way. To eradicate every doubt in this particular addition method, can you do it this way? You know the addition, the population. Now you write the numbers up to the number of the this population we are talking of. Then everybody will come and take one. Then if you are starting on the 12th, then you call number 12. Whoever is holding the 12, then that person comes out. 17 comes out. 22nd comes out. 27th, 32nd, 37th.
That's exactly what you're doing. So you pick the first person randomly. You pick the first person using random sampling. And then
since picking the first individual is also makes the whole thing addition automatic. So to avoid that automatic.
No, the first one is not automatic. The first one, I can pick the first person randomly. That's what I need. The first one, you see here, I wrote this number. So the number here, I can even put this one. You see, I'm going to, so you define what the approach you will use before you start the experiment. That when I go there, how am I going to start? So how you are going to start, then you say that I'm going to pick the first person using simple random sampling. So you pick the first person. So let's take it this way that the first person I'm going to do, I'm going to pick it from 1 to 10 randomly. So I write 1 to 10 numbers in a pot. And then I can even write 1 to 20, and then I'll shuffle it. Okay, I'll shuffle it, and then eventually I'll pick one randomly. So when I pick it randomly, I pick 7. Then I'll say that from 7, I'm now going to pick plus 5 again. So I'll pick the 12, the 17, the 22, like that. So it goes on and on and on and on. So the first one, I'll pick it randomly. Okay. But what makes it simple is that I'll just use the number. So it's very simple. Okay, it's very, very simple. Like to do. It's not really cumbersome because you just pick the numbers. Okay. So after that, once I pick my first number as 7, then I'll say that 12th person come out, 17th person come out, 22nd person come out, 32nd person come out, 37th person come out. Okay. So in this case, it actually makes it very simple. Okay. All right. So what other disadvantage again? What other disadvantage again? Any other disadvantage?
Hello, sir.
Yes, please.
Sir, can we say, since the first person is selected at a random, having a crucial starting point, we can then say it is having a bad way of starting?
I'll pick it randomly. So I'm still picking the first one randomly. And once I'm picking the first one randomly, there's no bias.
Okay.
Okay. We can argue in different, but once I'm picking the first one using simple random sampling, okay, the first one is crucial. That's why I'm using simple random sampling to pick the first one. Okay.
Lisa, can you say the first the selection of the first individual deviate from the entire population?
No, it will not deviate. It's not deviating. That one is even the perfect one. Because that one, I pick it using simple random sampling. So that one is no deviation at all.
And then the rest follow a certain pattern.
The rest follow a certain pattern.
Which is not randomly.
Yes.
As
so
compared to the first.
The rest is not technical. That's why our brother said that may not be truly random. Okay. All right. Okay.
But there could be errors in the sense that a mistake in choosing the starting point or probably the interval can affect the entire sample.
I chose the starting point using simple random sampling.
Yeah, so a mistake. Starting point.
Where mistake wherever any sort of work I do, once I start with mistake, it will affect everything. Okay, I get your point. Your point is that if I mess up the first one, it will mess up everything. Okay,
exactly.
Right. Okay. So then I will, which means that the starting point affects the subsequent ones, right?
Exactly. So
that's the point you're making here. Okay. Okay. So the starting point. Okay. That's why our brother said the starting point is crucial. Okay, I will accept it. Okay, the start.
But please, sir, the starting point you are using random sampling.
That's what I'm saying.
Why? So how do you mess up?
Let me.
That's what I'm saying.
Come in with that one?
So you come in.
Okay, let's say you have 100. You have 100 in 100 population or 100 peoples in the population, and then you are choosing 10. Now, if you are choosing 10 people from this population, and then you decide to choose your first starting point from a random sampling of 1 to 5, it means that those from 51 to 100 will never have a chance of being selected. But if you decide to choose your first sample random number from 1 to 10, it means that those from 50 going will have a chance of being selected. That's why the first starting point is very important.
And then what it also means is that, for instance, if the starting point is 3, let's assume it is 3. It means that any addition of 3, if we have about 100 of the people forming a population, it means the last will end at 99. What happens to the remaining one, which makes it 100?
Yeah. So you have a point.
Yes.
Yeah. But we can, because the starting point, we will be using simple random sampling. We can decide that we are choosing the starting point whereby each individual will have equal probability to be picked. If there are 100 there, we are choosing the first person randomly. So let's take it this way, that we put the papers there, We'll put papers in the electronomers in the container, and we'll pick the first number from 1 to 100. There are 100 people there. We are picking 10 people. They will pick 1 out. They will pick 70. Then the 70, we can choose to decide, okay, whichever way we'll pick it. Okay, it's 70. All right, we can decide that, okay, so from 70, we'll count the next 5. Now, if we pick 70, as our brother said, if we pick 70, what about those? What about those in 10? Okay, if our starting point is 70, so that is why we usually will pick the numbers from the early part. We'll pick the first number from the early part. Okay, like in this case, I decided that I'll pick it from the first 10. Okay, I'll pick the number from the first 10, and when I pick up from the first 10, then we decide that the 5th number from the number that I pick will be in that sequential order. So yes.
In that, doctor, in that case, if the participants are 100, and you decided to narrow it to the first 10, where is the random sampling there? It means that you didn't give all of them the equal chance of being selected.
Equal chance of being picked. Okay, so you see that the first number to decide where to start is not the first individual that I'm picking. Let's take it this way, that I want to decide where should I start. Okay, so I've taken the numbers 1 to 10. So where should I start? Where should be my starting point? Then the starting point, let's say I've picked, let's take it this way, that let's say I've decided to pick from 1 to 10. Then I pick the number from 1 to 10 randomly. Then from there, I will add the 5th number going. So I get to 100. So yes, the first, even though it's not truly random, at least there was I didn't bias the result from the onset, because I wrote the number, put the number 1 to 10 in calabash, choose the starting one randomly, then I will add the rest in that. Maybe I'll add it plus 10, plus 10, plus 10, plus 10. So the first one will be chosen randomly. Okay. It's the issue of the starting point being big 10 is where we are contemplating. But I think because I will use simple random sampling as starting point, I don't see the starting point as so much of a big issue. Okay, but what our sister is also saying here is that because I wrote the number 1 to 10, which means that I didn't give everybody, even the starting point, I didn't give everybody equal chance of being picked. Do you get an argument? Because I wrote 1 to 10. What about if I had written 1 to 100? And then I'll pick one randomly. Then I will do it sequentially. Okay? But as I said, we can even do it that way as well, and it still holds. But you have to make sure that you define that terms, and you define it in the beginning of the experiment before you start the work. Don't decide it in the middle. Decide it before you go and pick your sample. That I'll pick the first one randomly. Then after picking the first one, every 5th one I will pick, every 5th house I will see. Okay, let's say I go to the village. I'm going to administer questionnaires, and I decide which house should be the first house. So the which house to be the first house, I can take arrow on this thing, and I will spin the arrow, okay, speedily, and when it settles, where the first house to point from the community center, that will be where I will start. And then once I pick the first house, which means that because I just spin it before I pick the first house, which means I chose the first house randomly, Then the second route is that I will, after I pick the first one, the subsequent one, I will count the fifth one. So from that one, I'll count 1, 2, 3, 4, 5. The fifth house from there, I'll pick that one. From there, I'll count the next fifth house, the next fifth house. So that is why we are saying that if I do the starting point using random sampling, then the other one, okay, because the starting point is random, okay, there shouldn't be so much of issue in terms of the starting point, because you do it using random sampling for the starting for the number one. Okay, so that is no matter what, honestly, no matter what we do, definitely there will be issues. Okay, but we define it this way: we are going across board from 1 up to 100. So we want a situation that will give everybody a chance here. So I can decide that I will pick the first 10, this one randomly. Which number randomly? Maybe the first one is 4. So I pick the 4, that number 4. Then once I pick number 4, then I will be adding +5 to 4, +5, +5, +5, +5 till I complete it. So this is how I'll go by it. Okay. All right, great. Now, another point that we need to be very careful is that sometimes maybe, you see, we'll be working on let's say we'll be taking interval. If you are not careful, the population may be sitting in a particular manner. Maybe all the boys are sitting in a particular manner. And if the boys are sitting in a particular manner, if you are not careful, we'll end up picking maybe only the boys, and we will not have girls in the list. So sometimes the risk is that if you are not careful, we will end up picking people that there will be maybe a particular manner of rhythm. Okay, maybe the people are sitting in a certain rhythm, some rhythmic manner. That's all. Maybe when we got there, people were sitting husband and wife like this. Maybe husband sit here, wife sit here, husband sit here, husband here, wife here. Okay, so this is the man and then the wife. Okay, man and the wife, like that. So if we are not careful, if there is some rhythmic pattern of the sitting, all right, rhythmic pattern of the sitting, if you are not careful, you could introduce some sort of some rhythmic bias. Okay, please, you understand what I'm saying here? Let's take it this way: that we are sitting there in the park. The man is here, the wife is sitting here. Man here, wife sitting here, like that. Okay, man, wife, man, wife, man, wife. If they are sitting in that manner, and then you are picking people, if you are not careful, another disadvantage that could be is that there could be some sort of something we call, okay, there could be rhythmic, rhythm, okay, rhythmic or periodic bias. If you are not careful, I mean, it's less likely to occur though, but it could be, okay. And then, like if the people are sitting in this manner, a man and his wife, man and his wife, you see, they're already sitting in a particular pattern. Let's say if it is church and we are using that method, and then people are a man and then the wife, man and the wife, man and the wife. So if we are not careful, if we are not careful, we end up picking all males based on the nature of the first number that was picked. Okay, if we're not careful, so they could be rhythmic, okay, or periodic bias. All right, good. And then another thing that could also could be, what about if they are strata within the population? We could miss it. okay, we could miss it. We could, if they are structured within the population, especially if the population is very large, let's say 2,000 people, and you are taking just 100. Okay, the probability that if there are some subtle groups, okay, there is a chance that if there are subtle groups, okay, all right, if there are some subtle groups within the population, we are likely to miss it. Okay, are you there? All right. So if there are subtle groups, some groups, okay, so subtle groups, some groups, okay, within the population, we can actually mix the word. We can mix the group, that structure within the population, especially if you pick it and then it doesn't fall in the number that we pick. Okay, that is okay. Well, that is why I think I'll come back. I'll say that the starting point, I think I'll accept it here. From the point here, the starting point is the most crucial. I think I'll accept it. I'll accept it. Because once you mess up the starting point, okay, all right, if it is, let's take it this way, if it is, let's say, stratified sampling that I'm doing, and then once I pick the first one even incorrectly by any error, it doesn't affect the rest. But here, the starting point, so I think I get the points that some of the our colleagues say we're raising. So the starting point becomes very crucial because once we mess it up, everything is in a mess. Okay. So here, when we use a systematic approach, there could be that if there are subgroups, okay, within the population, we are likely to miss it. Okay, we can mix subgroups within the population. All right. Any headache so far? 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 Are my people there? Are they tired? Are you people tired? Do you need a break?
Yes, please. We need a break.
Okay. Let me give you. Okay, so let's come on top of the hour. Let's come exactly 3 o'clock. Let's come exactly 3 o'clock. Then maybe we'll do 30 minutes more. Okay, let's come exactly 3 o'clock.
Thank you.
We'll do 30 minutes more. Okay, so
I see you. I see you.
I see, Bright. I see you as well. All right. I see you as well. Okay. So while you are coming back, please try and then while as you are doing your listen, please try and then let's see do something on the cluster sampling. Okay, the last part of cluster sampling. Okay, so when you come back, we'll look at the advantage. Okay, advantage and the word and disadvantage.
Please do save this update so that we have it after.
Yes, sure. I will do that. Okay, this one is even blank page I'm using, so it's okay. This is blank page that I'm using, so it makes life easy. Okay, so advantage.
So say when are we coming back?
Oh, we're still on top of the hour. It's 3 o'clock, and then we'll do some 30 minutes, and then we can call it a day.
Okay, thank you, sir.
Thank you.
Thank you.
The kind of way you chop that one. Boys, what is it? The mistake boys are. You
Okay, table. Wow. Coach it nam. Inavayo no nama. Anglo headina. Anglo headina. Heading ka anglo. Spell the gun. Okay. Amount. For both it came up. Open total any.
Hello, my people. Hey, people have.
Hello, sir.
People have still not resumed the wage. Yeah.
So we have resumed.
Yeah. It's not that people are coming out from their hideouts, from the fufu and then the akle. Yeah. Even myself, I allow some of the stuff to go down. You know what I'm saying? Okay, so okay. That's my trial question. 10 questions for you. Hey, why are my people?
So we are here.
I can see Alaji and Kofi Aaron just coming.
Oh, I was here a long time.
Oh, is that so? Okay.
Yes, sir. I didn't go for break.
Oh, that's good. That's good.
I don't have money, so I didn't go for break.
Oh, is that so? Oh, come on. Then you should have told me because Angela is just returning from break. Okay. Yeah. She could have ordered some pizza for you. Okay. Men cry, we don't like pizza. We like Baku and Wachi and stuff like that. Okay. I think we need to 1 minute's time. We are starting. It seems folks have gone overboard. So just 1 minute's time. We are starting. Okay. So we're going to start. So, okay. So the first thing is, and bring this one down a little bit. My first question on the board is, when is random sampling, when is cluster sampling used? When do we use cluster sampling? Yes. What is cluster sampling at all? What is it? What is it? I don't know what it is. Yes. Somebody should help me. Yes. Oh, my people. Are you not back from break? Yes. When you talk of cluster sampling, what is it? What is it at all? Yes.
Okay, sir.
Okay.
For the cluster sampling, you put the individuals into various groups.
Okay.
And then you randomly select you select your sample from the groups.
Okay. So let's see. Let me put down the points you phrased. So you put the word, so individuals
into groups or clusters.
Individuals are placed the word placed into groups, and then go ahead.
And then you randomly select your sample from the groups.
Okay, you randomly select from the group. Okay, great. I think pretty much you've given the definition. So when do we use it? When does it become necessary for us to use this method of sampling? When do we use it?
Hello, sir.
Yes, please.
Okay, sir. It's normally being used when the population are spread geographically.
Okay, so this one is we use it when so it is used when the population is spread. Okay, you understand that the population is more or less spread. Okay, great, a little bit dispersed, like scattered. Okay, when the population is spread or dispersed, right? Is that not it? Population is dispersed, all right, geographically, geographically, Okay, something of this nature when the population is spread, okay, or scattered geographically. Okay, good. All right, nice. Okay. Now my question is this. Okay, so now because of what you just said, my question for you is this. What is the difference? Okay, because of what you just said, so then I'll bring this my question here. I'll bring this question first. Okay, so let me bring this question first. Okay, so based on what you just said, then my question goes to you. What is the difference between stratified sampling and cluster sampling? Yes. Based on what you just said, now what is the difference between stratified sampling and cluster sampling?
Okay, so the cluster sampling or the cluster sample, we divide the population into groups. Then we randomly pick a group, then we sample.
That's what.
But for the stratified sample, we divide the population into groups. That is the structure. Then we sample each group.
Yeah, what you said and what is the same thing. You've almost repeated what you said.
No, sir, he's trying to say that for the cluster, you put the various or you put the participants into groups, and then you pick the groups as your sample.
You pick the group as a sample.
Yeah, as a sample.
You don't sample individually from the groups.
No, you don't sample individually from the group. You use the groups as your sample randomly.
All right.
And then for the stratified, after dividing the population into various groups, then you sample from the individual groups.
Okay.
You sample individuals from each group.
Okay. I think this one, let me get a picture for you so that it will be clear. So what is the difference? I don't get the difference. And I'm sure your friends are not getting the difference. Let me get a picture for you so that it will be easy.
With the cluster sampling, the groups are created and randomly selected to form the sample, while the stratified one, the creation of the strata is made before sampling is done.
Okay, good. Okay, what does it mean? I still don't understand. Can you say it in simple terms for me? Can you say it in simple terms for me? Okay, let's see. Let's see whatever I'm picking a picture. That is why I've not typed what you say. Okay, well, let me see. I'm picking a picture so that.
But in a stratified sample, selected individual are maybe members are selected for sampling. By the cluster one, all members are as all members are picked in the cluster for sampling. That's what I noticed.
Okay, let's see here. Let's see. Let me bring a picture. Okay, good.
For the cluster, when you put the participants or the population into groups, and then you pick your groups as a sample, all the members within the group are included in the sample.
Okay, good. Okay, so good. So let's see. So observe this one. Now look at what he said that I wrote. Okay, you see, he said individuals are placed into group and you randomly select from the groups. Okay, look at the definition he said and look at the picture here. Then let me bring one picture too for you. Okay, and then whether you spot any discrepancies. Can you spot anything? Can you spot anything there? From what he said. Let me put this one. Okay.
Look.
Can you? Yes, please.
I see it this way. They are both. The selection is the same, but only that with the cluster, the population is rather spread wider and all over the place. In that, to bring them together will be very difficult. But with the certified, the population could be at the same community, but how to bring them together at a given space will be a problem. So therefore, you sample this from the various group and bring them together.
Okay. All right. So let's see here.
The geographical.
Look at the definition. Look at the definition there. I want you to look at the definition at the top here and see whether you can spot any issue with it. That's what I'm asking. The definition that our brother said that I typed. Okay, so look at it carefully and see whether you can spot any issue. That's can you spot any issue? Okay, look at my picture I've put it here. Look at the picture I've put here. Can you spot any issue with the definition? Can you see it?
So I think it's the grouping.
Yes. What problem can you spot from the definition?
So it didn't clearly define how you are going to cluster the population or the groups.
Okay.
No, look at it. It is randomly.
Okay, he said that
them into groups. Didn't say.
So the randomly could be a school or village or.
Okay. All right.
Or church.
The classes should have let's say should be heterogeneous, like they have different characteristics.
Okay. All right. Okay, so you can see here what individuals are placed into groups. Then you randomly select from the group. Okay. So in this case, you see, you are not going to select individuals, all right? But you randomly select from the group. He's still right, slightly ambiguous though. The randomly select from the group, it looks like you are picking individuals from the group, but I think he's still right. Okay, so randomly select. So here, in this case, our sample here, what we are sampling is the cluster becomes our unit, our sample unit. Do you get it? Our cluster, like you see, so this is the population we're giving. Now this population we're giving, then we put them into what? We put them into various clusters. So those people are here, those people here, those people here, those people, we put them into various clusters. Then we randomly select these clusters, these groups. So not necessarily from the, so here we randomly select from the, we select randomly from the, random select from the groups. Okay, all right, okay. So, but here maybe into clusters. All right, okay. Okay, so let's put clusters here. All right. Okay, I think you're right. You're right. Okay, I'll still accept it. If he had said that we randomly select from each group, that one is not, that one wouldn't be cluster sampling. So here, what we are, our sample units are the groups. Okay, so you can see that when we're, so here, we group them this way, we group them like that. So this could be various churches or various schools, various political parties or something like that. So what happens is that we put all those groups, okay, various churches and stuff like that. Let's say in the district here, I'm going to conduct maybe talk on let's say new curricula we've introduced. Okay, I'm going to give a talk about COVID or Ebola or something like that. Okay, so once I'm going to give a talk, you see, I can't do for the whole of the Cape Coast. It will be difficult for me to do it. But what can I do? So on Sunday, people will be going to church. Okay, so then let me pick the churches random. So then I just group them. So these are cluster here, 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 here. Then I'll pick from the cluster randomly. Okay, so now you can see from here, so I have a cluster of population. So 1, 2, 3, 4, 5, 6, 7, 8. So then I pick from these, so I can give them numbers, and then I decide which of the churches should I visit, which town should I visit, or which school should I visit. All right, then I can give all these ones numbers. Then for me to do the sampling, the final stage of the sampling, that each of these groups, okay, all right, this one like that here. So then I will pick the cluster here as my sample units rather than individuals. So I'll pick, let's say, that this church here or that church there, this one there. Okay, maybe church at UCC, church at Kwapro, church at Abra, church at Agri, church at National, church at Adusco, church at Fanspim. You understand that? So basically, what I'm just trying to do is that so you put this, because you can see this is widespread geographically, they are spread. So I want to visit the place and go and give a talk about maybe COVID and birth control and stuff like that. So maybe we've decided to choose schools. All right. So if you're going to choose schools, what are you going to do? So we pick the schools into clusters. All right. We pick the schools into clusters like the way you can see from my screen. Now, when we put the schools various into clusters, then where should I visit? Then I'm going to choose. I can put this one 1, 2, 3, 4. I can give them numbers 1, 2, 3, 4, 5, 6, 7, 8. Then I can put these numbers in what? In a pot and randomly pick 4 places. So when I pick them randomly, then I pick these 4. So these 4 were randomly picked, and these 4 are the clusters. So in this case, my sample units are not the individuals, but the clusters, the groups that I have created. Okay, good. Now, the question that I asked is that what is the difference between this and stratified sampling? Okay, so for us to do that, what I will do is that I'll bring, now look at the difference here. If you look at the stratified sampling on the screen, you can see that, look at the population first. Look at the population. You see, this is the population. Mixture, purple, blue, green, red. All right. Now, before I do the sampling, what do? I put them into strata. So strata means that I put them into groups. Okay. I put all of them into groups like that. So here, I put all of them here into groups. You can see that there are various groups here. All right. And based on the type of question that I want to answer, I want to account for the various strata within the group. Then, so these are the groups. Okay. So you see that I've organized them into various strata. They are not mixed up. So here, in each strata, they are only females, like the way I did it previously. All the men and all the women, okay, all right, all the men, all the women in there, all right. Then after that, I will do this thing. I will sample from each strata. Did you understand that? Okay, so here like then we wanted to get each equal in each case, but that's not what we always do. Okay, sometimes we can sample according to proportion, or we call it proportion to size. Okay, so each group, when they are more like, and the normal circumstance, ideally, because they are more here, this diagram is not really depicting it very well. If there are more people, more this thing, deep blue here, we'll pick the more of the deep blue or the purple here, right? We'll pick more of this. So what happens is that in the case of stratified sample sampling, you see that we first of all block it into the strata, and then the strata are homogeneous. Okay, can you see that the groups are homogeneous? So this is the population. We blocked it into strata. So with the strata, they are what? They are homogeneous. Okay, so you can see that here. You can see only green, only purple, only red, only blue. So out of these ones, then we randomly select from each. So we randomly select from here, randomly select from here, randomly select from here, randomly select from here. Please, do you get a difference? Okay, maybe let me put them side by side. Is that not it? Okay, let me put them side by side so that okay, let's take it this way. So let's see what is the easiest way we can illustrate this. Okay, let's see.
It's okay. It's okay.
Okay. Okay, all right. I've seen some. I want a diagram that will make everything easy for me. Okay, let's see. Let me see whether I can get a diagram here. Okay, let's see something like this. Okay, so let's see. Okay, good. Okay, let's see something. I want a diagram that's going to simplify everything. Okay. Okay, let's see something here. Okay, let's see something like this. All right. Okay, so let's see. So here, okay, so something like this. Now, if you look on my screen, okay, if you look on my screen, all right, so systematic sampling. Okay, so if you look at random sum, everything is here, and then I'll pick, each one could be picked randomly. In the case of stratified sampling, I first of all block it into, oh, this one's not even illustrating it the way I want. You know, it's not doing the way I want. Okay, so let me pick this. Let me pick this side by side. This one here. Okay, and let me pick this. Okay, great. Like this. All right, great. So now let's look here. So in cluster sampling, in stratified sampling, the structure that we will create homogeneous group. The group is homogeneous. If it is female, females throughout, males throughout. Okay, that's what we do. All right. If it is a woman that I'm creating a cluster, I will have maybe teenagers here. Maybe the drug I want to test. It's maybe children under 10 years. Then go to teenagers, go to maybe expectant women, pregnant women, go to adult women, and see how the drugs is going to work in each of them. Okay. So first of all, you block the population here into, you stratify the population. And so in this case, they are what? The groups are homogeneous. You can see that these are female population here, children, expectant, adolescent women, expectant women, and maybe normal women. Okay, all right, good, like that. And then so each of them, then I will sample them and I'll give them the drug. In the case of the cluster sampling, what I will do is that because the population or the place is geographically spread or dispersed, what I will do is that I will create a cluster out of it first. Okay, so this is my cluster. That's the cluster that I have. So I'll create this one cluster, another cluster, various cluster. You see the cluster here, they are not homogeneous. You can still see a mixture of the yellow and blue. All right. So in this case, I will group them Okay, I'll play them into groups. That's a cluster, but the cluster here, the cluster is heterogeneous. Unlike that of the stratified, that the cluster here, they are what? This structure that we have here, they are homogeneous, males, females. And even if they are females, you see, I have children, adolescent age, expectant women, normal women, women in menopause, like that. Okay, you can create various layers, but each layer is homogeneous. And then from each layer, you sample randomly from each layer. In the case of cluster sampling, okay, what happens is that your unit is not an individual, it's not Kofi, it's not Kwame, but the unit is what? It's actually it's a group. So when you are sampling, you sample a whole group. So let's take it this way that I'll pick those. Some people are from, let's say if it's this class, some people are from Bolga, others are in Westco, others are in Temale, others are in Takrady, Holy Child, okay, UCC Center. So let's say these are the various clusters in each case. So UCC Center, Bolga, Westco, Techiman, Sunyani, Accra, Cape Coast, Seshi, my people, Seshi. Okay. Koforidia, okay, Koforidia, yes. So all these ones, so these are good, but I'm asking that which place should I go and give the talk? Okay, so I give all of them number 1, 2, 3, 4, 5, 6. I want to just go and give a talk there. So which place should I go? So out of these numbers that I give, 1, 2, 3, 4, 5, 6, 7, 8, then I'll put them in a pot. Then I'll pick 4 of them, 4 of the groups randomly. And then so when I pick it, so I ended up picking Bolaga, okay, Seshi, Koforidia, and let's say anyone where my ladies are, please.
Kaswa.
Kaswa, I'm scared. Oh, Kaswa, I'm scared.
Don't go to Kaswa.
Don't go. Scared.
Kaswa people, they will steal our team.
Yeah. Oh, one lady is at Kaswa, so I'm safe. I've heard.
They will steal our team.
Yes. So once my lady is there, I'm fine. My lady is there, I'm fine. Okay. She'll take care of me. I'm fine. All right, good. I hope I'm not coming back to say that I trusted my lady. Trust me. So here, in this case,
it's not offended.
So in this case, I've picked Bolaga. So randomly, I pick Bolaga, I pick Techiman, I pick Seshi, and I pick Kaswa. So with these 4, these are the places that I'll go and give a talk, okay, or maybe the COVID and stuff like that. Okay, so you can see that here the groups are what? They are heterogeneous. But here the groups in the stratified sampling are homogeneous. Have you seen the difference? We just put male on one side, female on one side, and we sample individuals from the group. No, this one we will create the group as our cluster. Okay, so this is we'll use the group, we'll create the groups because they are geographically dispersed. Then we'll pick the group becomes our sample unit. Okay, here the unit is the individual. Okay, so we can see that here the unit is the cluster. So we'll pick so this is the church, the town, the school. Okay, then we'll pick those ones to visit. Okay, so that's the cluster sampling. Okay, good. So now that the explanation is clear here, okay, when do we use it? We've talked about when we use it. Okay, we said when the population is what? When the population is dispersed. Okay, all right, large population, but it's dispersed. Okay, good. Now let's see some of the advantages, and then advantages and disadvantages. We can call it today. Okay, so what are some of the advantages? Yeah, what are some of the advantages and disadvantages of what? What are some of the advantages and disadvantages, please? What are some of the advantages and disadvantages of cluster sampling? Okay, looking at this picture, you can see from my screen. What are the advantages and disadvantages? Yes, please. Yes. What are the advantages? Yes. What are the advantages? Yep. Please, I'm listening.
Hello, sir.
Yes. Yes.
It is good for large. It is good for large areas.
For large what?
Areas.
Okay, it's good for what? Large areas. Okay, when the population. Okay, so it makes it feasible. Okay, good. So it's possible for what? For large what? Okay, large vast area maybe. So suitable for large what? Large. Okay, spread. Okay, I will qualify large dispersed. Okay, dispersed population. Have you seen it? Okay, large dispersed population. Good. That's nice point. Any other points, please? Large dispersed population. Good.
Look, it is cost efficient and time efficient.
Yeah. So why do you say it is time and cost efficient? Why do you say it is time?
Because you are targeting the clusters instead of the individual people, individual population. It saves time and then money.
Oh, okay, good. So it is what? So which it is the cost and what and time what? You say it is cost and time effective. Okay, cost and time effective. Okay, cost and time effective. All right, good. That's nice point. Okay, because you are not picking individuals from here. So in terms you are picking groups, and because you are picking groups, it's not all that expensive compared to a stratified sampling. Okay, that's a very good one. Okay, good. What else again?
It is easy to do with.
Organize.
Okay, good. So easy to organize. That's a good one. Easy to organize. All right, that's good. Okay, good. Easy to organize. In terms of what? In terms of what?
In terms of grouping the population naturally, say schools, villages, communities.
Okay, you see that some of them, even some of the groups are even naturally in existence.
Naturally, yes.
Have you seen it? For instance, if I want to go to the schools, I'm not the one creating the schools. Okay, if from UCC here, St. Augustine's is just at the top here, UPSS is just here, Wesley Girls is just at the back here, Adisco is just here, National is just at the back there, Agri is there, Fanspin is here. So it is easy. Ednaman is just at the back of me here. You see, so you can easily rely on what? Naturally, okay, the naturally existing groups. Okay, so it makes it easy, very convenient to organize. Okay, even in terms of resources wise. Okay, through data. Okay, by the time you get to this, if you call the schools that you are coming, by the time you get there, I'm sure the teachers might even organize a kit for you, because the groups are already in existence. Do you understand that? So it makes it easy for you. Okay, so it is easy to organize. That's a very good point. What else again?
So you don't need to know the entire population.
Yeah, I don't need to. Trust me. Okay, so in terms of information, prior knowledge. Okay, so prior knowledge. Okay, prior what? Knowledge. Okay, knowledge. Okay, knowledge of the population is not what required. Okay, it's not required. Okay, I don't necessarily need to know. Okay, it's not really a prerequisite. All right, I don't necessarily need to know the population in entirety, everybody there before I can exhibit. I can actually carry out this one. Okay, good. I think that's a very nice point that you've raised. Okay, so it is cost and time effective, as our brother said. It's easy to organize because you can use the natural groupings. Okay, if you are using school churches, the churches are already in existence. The mosques already in existence. So we'll just use those natural groupings, and then it will make life easy. All right, good. Now let's see the disadvantages. Okay, let's see the disadvantages. Okay, all right, disadvantages, and then we can call it a day, right? Okay. Disadvantages, yes. What are some of the disadvantages? Yes. What are some of the disadvantages?
Not suitable for small populations.
Not suitable for small population. Okay, if the population is small, if are you creating a cluster means you're even worrying yourself.
Yeah, it's the wider.
Yes, yes. Good. So okay, so not okay. So here, not suitable for small hops. Okay. What else again? What else again? What else again?
So, the clusters can decide to refuse the population, the data.
The cluster who can
They
do
can
it.
refuse to give the data. Like maybe if you choose to go there, they can decide to turn you down.
Oh, is that so? What about let us assume the all other things being equal, you can still get the data.
Oh, okay.
What's likely to occur? Yes. Now, what is the main advantage here? If you look at this, what's the main advantage of this one? What's the main advantage of stratified sampling? The main advantage.
Hello, sir.
Because it is homogeneous.
Hello, sir.
Yes. Hello, please.
The main advantage is about its precision.
Okay, it's precision. Now, okay, well, what about, you see, remember that I said that usually when you do cluster sampling, it's the sample you get is adequately representing the population. Okay, I mean, this one they did equal sample. That's not what we want. Usually we sample proportion to size. If there are more blue, pick more blue. So usually for stratified sample, random sampling, the sample will get adequately represents the population. But look at the population here, and then we sample. We are going to take cluster. You know, some clusters will be bigger than other clusters for sure. Some even in churches. So I put churches. Catholic Church, the members are bigger. Pentecost Church, the members are bigger. Methodist Church, the members are bigger. If I pick a church like Kwame Chrome International Ministry, okay, all right, or Kwame's Ladies Ministry, you can see clearly that a church like that, you can see that the members are not all that many because it's a relatively new church. Okay, so the members are not all that many. So you see, this cluster that I'll pick may not adequately represent the population. Do you get my point right? Okay, it may not, because you see, I put group here, and the group is not like the other stratified sampling. Eh? You group all the girls here, all the girls and all the boys, then you pick it from each of them. But here, no, we'll pick here, we pick the groups, and the groups, I pick Kasua, Seshi, Bolga, and then which one again? Techiman. So you can see clearly that if I take the map of Ghana, I only sampled here, I sampled Kasua here, I sampled Techiman here, and I sampled Bolga. So look at here, the whole of Ashanti region untouched. Ashanti region and Volta region untouched. Okay, Oti region untouched. Okay, BA untouched. The whole of northern Ghana untouched. Okay, it's only Bolga here. Have you seen it? So here it is not adequately representing the population. Okay, unlike stratified sampling whereby the population adequately represented. But here with a cluster sample that I did, okay, this one I did. Now I picked this one, and it doesn't adequately represent the population. So here the sample may not adequately, all right, represent the population. Okay, so here the sample, okay, may not what? May not adequately represents the hub. Okay, what else again? Okay,
so can we also say that because of its heterogeneous nature, there will be high risk of bias.
Okay, good. For instance, you see, yes, I agree. All right, you see that, for instance, if you pick here, let me even take the map again. You see that people here, if you sample Cape Coast and Takrady like that, most of the time, let me even pick Sekendi and Takrady. Sekendi and Takrady are pretty close, okay? And if you go to Sekendi is my mom's hometown. Now, the same people in Sekendi, they are the same people in Takrady. The family members in the people you see them in Sekendi. When you come to Takrady, they are the same family people. Like people from Sekendi, they migrated to. They are the same people in Sekendi that there are some people came to buy land in Takrady. Okay, so you see, if you pick here, if you randomly pick, let's say, you sample Takrady, you put the towns together, and then you sample Takrady in Sekendi. Eventually, your analysis will be biased because the people in Takrady, they are not different from those in Sekendi. They only separated by geographical names, but they are not different. Okay, so likewise, let's see if I go to Wa and let's say Nandom. Okay, the people there, they are almost the same. Maybe somebody say, oh, why is a capital city? So somebody at Nandom will now buy land at Wa and build nice house there because. So if I do cluster sampling and I ended up sampling, let's say when I pick it randomly and then I pick Wa and Nandom, at the end of the day, I will bias the word. I will bias the results because of what? I will end up introducing some sort of what? Cluster, some sort of error in it, in a sense that individuals, let's say if we are geographically close, we are likely to be more alike. Are you there? When we are here, like the way I gave instances of Takrady and Sekendi, okay? They are the same people in Takrady you find, the same people in Sekendi that you find in Takrady. So that assumes there's something similar. The same people you find in Wa, they are the same people you find in Wa, in Nandom. Okay, let's say you come to Volta region. Okay, all right. So you come to Volta region and you say that let's say.
Hello.
I'm listening.
Hello, sir.
I'm listening to you, please.
They could be the same though, but whatever the information that you want from them might not be the same.
Yes, it
though
may not
the
be
population
the
is what you want, but whatever that you want from them will not be the same.
Yes, you are right. But the point is that probability that if I sample people that are close, okay, you see the one thing we always consider about sampling is that I want the sample to represent the population as possible because it is cumbersome for me to get entire Ghana. So what did I do? I decided to, these natural groups that are already there, okay, I want to pick maybe 20 districts to go and sample from there. Then I put all the districts in Ghana into a container, and then I select them randomly. And when I selected, I ended up selecting Takrady and Sekendi. So you see, because Takrady and Sekendi are closed geographically, they are likely to be homogeneous in terms of the information they will give me. Okay, unlike if I picked one from Takrady, I picked one from Ashanti region, let's say Kumasi. I pick let's say Bebieni. I pick let's say Tichiman. I pick Damba. Okay, I pick Damango, like that. See, I pick Tamale. So if I do it like that, okay, if I do it like that, then it is well. Then it remove the biasness. But because I am picking cluster, there is a tendency, okay, it could happen that I can, the two districts that I ended up picking Takrady and I picked Sekendi as well. Just later, I ended up picking Wa and Nando as well. Or I ended up picking, let's say, Oliga and Sandama. Okay, all right, because they are all the same people. Okay, even though I won't say that people who are in Navrongo, they are the same as Bolaga, but because they actually exist in the same geographical location, they are likely to provide me with similar information. That's the argument I'm trying to put across. Okay. In fact, from Bolliger to Sandama is quite a distance. It's quite a distance. But because they are all here together, but at least if I had picked one from Bolliger, and I picked one from Wa, pick one from Damango, Tamale, and then Bonum, Tichiman, like that. If it is what that beautifully spread like that, that would be awesome. But because I ended up, when I created a cluster, I'm picking the clusters randomly. I will end up picking Cape Coast, okay? Cape Coast, which is, let's say, one district. And let's say I'll pick, let's say, Mori, which Mori is just adjacent to Cape Coast, okay? It's just a stone throw. Or maybe I'll pick Salt Pond, which is not that far from Cape Coast. And so the tendency that the information Cape Coasters will provide me will be similar to that of people from Salt Pond. Is very, very high. Okay, so that is where we are saying that there's that possibility of introducing what? Introducing sampling error, okay, or high risk of bias. Okay, all right, there's high possibility of introducing what? Some sort of what? For there's high risk of introducing some sort of what? Error in the sampling. Okay, so sampling error could exist. All right, that's the argument you are trying to put across here. Okay, so here, high risk of what? There is what? There is a high risk of what? Of sampling error. Okay, all right, because what? I could pick two groups that are close to each other, and then they will end up providing me with similar information. Of which, if I had picked one from Cape Coast and I pick one from maybe Adangwe, go and pick one from Atketa, okay, go to Ho, okay, then move on to maybe in that manner. Then that one, the information I'm likely to have diverse audience and stuff like that. Okay, any last point? Last point. Yes. Yes. Any last point here? Now look at this one. See, look at the way. Can't you see? By the time we finish, the sample will be too much. Can't you see? Because you are picking clusters, and you are picking. Let's say you pick the whole church. Can't you see? By the time you finish, because each cluster, in fact, we wouldn't even quantify what's in the cluster. If it's a school, by the time you finish that, let's say you are going to give some sort of sleeping net, insecticide treated bed net to secondary schools. And then look at the way you picked it. I picked schools. So let's say randomly, I picked the UPSS from here, which is Stonto from here. Let's say I pick Abisko there. I pick National there. I pick, let's say, Mankesim High there, randomly. I'm picking the schools around maybe Central Region. Okay. Now, if I go there, if I go to UPSS here, there will be over, at any time, there will be almost 2,000 students on campus. Okay. You see, if I go to Abisko, maybe similar number. If I go to Mankesim High, maybe 800. If I go to maybe about 1,500. If I go to maybe Agre, maybe 5,000. No, maybe not 5,000 be on the high side. Maybe 2,500. Okay, all right. So you can see that at the end of the day, my sample size will be too large. If you look at that. What do you think? Okay, my sample size will be too large. Okay, all right, too large. My sample size. Okay, sample, all right, the sample size, okay, maybe, okay, too big, okay, too big. All right, good. So maybe we'll end our class here. Thank you so much for having me today. It's Christmas season and you guys are squeezing time, okay, for us to have the class. Thank you so much. I will try and then I'll get you some, I'll send a slide, but I will try and get you some trial questions later on, okay? because we are also going to look for some bankubi and stuff like that to quench things. So thank you so much for having me today, and thanks you for your time. I wish you all the best. Yes.
This slide.
Yes, I'm going to give
You're
you this slide.
welcome.
Okay. Yes, I'll give you this slide. Okay, this annotated stuff that will to make you understand the class very well. So I will
Thank
save
you,
this
sir.
one and
God
share
bless
it.
you.
And bless you too. And bless you too.
Class rep, try to add me.
I see you, sir. I see you. I see you.
I see you. I see
I see you. I see you. I see you.
I do see you. Okay, I do see you. I do. All right. So I will save this one and then I'll make it available to.
Okay, sir.
Thank you. All right. So
No
have a good
problem.
day and God bless you.
God bless you, dog.
Okay, please have sent it. So course reps here, please have sent the new one to your group. So please kindly forward it to your group members.